Good morning, good day from Lisbon, Portugal, and welcome to Geomundus 2020. This is the pre-conference registration session, as I said before. Please feel free to chat a bit with your fellow attendees. I see some interesting chat going on right now, people sharing where they're from, which time zones they're in, etc. Very nice, very interesting. We are all GIS enthusiasts in the end. So to begin with, my name is Ian Lin. Everyone calls me Lin. I'm Taiwanese, born and raised in Eswatini. I'm one of the anchors for today's schedule, and right now I'd like to go over a few announcements for the conference. Firstly, please fill out the poll that will be appearing on your screen right now. It should be letting us know which workshop you're interested in. This is so that we can kind of take a head count for how many people will be in which workshop. The workshop info will be presented as probably emailed to you already, but the poll will be appearing right now. As you can see, there's session A, B, and C. They're running simultaneously, so you can practically only join one at a time. So pick your best option. And we look forward to seeing you in those workshops and webinars. Second point of the announcement is that just a reminder for our presenters and speakers for today, time control is going to be pretty hard to regulate. We will try to give you a little nudge just to tell you when there's only about a minute or so left of your presentation, so we don't run over time and we have more time for your questions from the audience. Thank you very much. Lastly, about the general chatting of the webinar, remember that there is both the chat and Q&A functionality. Chats is what you're using right now. If you want to pose a question for a presenter, a keynote speaker, perhaps a panelist, we advise you and we strongly suggest you use the Q&A function, because in chat, your comments and questions may be lost, whereas in Q&A, it will be saved. People can upvote if you feel that the question that was asked by someone else is very relevant. You have to share the same opinions. Or you can even raise your hand if you would like us to unmute you so that you could ask your question orally to the presenter or the panelist. And again, obviously, please be very kind and respectful and keep track of how much time you're taking because there are many questions and many attendees. So hopefully we will try to make as much time as we can to get everyone's questions answered and give everyone enough time. And yes, we will begin in about 5.5 minutes. So please just have fun in chat, network a little bit, and welcome to Geomundus. Good morning, good day, and good evening to everyone. I would like to welcome you to the 12th edition of Geomundus Conference. My name is Ian Lin. I am part of the steering team of Geomundus 2020. I am from the Kingdom of Eswatini, but my parents are from Taiwan, which is why I look like this. I studied biology and environmental studies, and I am very interested in how GIS can be used for sustainable development across the world. My team and I will be your hosts for today. And we are based in Lisbon, Portugal. Perhaps you can see this wonderful mural behind me. I'm not actually near the ocean. I would like to introduce my fellow anchors, Iftihia and El, as your hosts. My fellow anchors, Iftihia and El, as well as your hosts for today, Carlos and Alejandro.
Thank you, Ian. May you all have a good morning. Thank you for joining us today for the very first Geomundus conference that is held entirely online. And hopefully you're just as excited as us here in Lisbon headquarters. My name is Iftihia Kukuraki, and apart from co-anchoring the first day of the conference, I have been working on the website content, design, and maintenance for the past 6 months, together with my colleagues Patron and Prezadi. I come from Greece, and my academic and professional background are from the fields of computer engineering and software development. I joined the Geotech Masters because I wanted to take my technical knowledge to a geospatial context. This was my short intro, and now please meet my colleague and co-anchor, Gabrielle.
Thank you, Iftihia. Good morning, everyone. My name is Gabrielle Morris, and I'm going to be one of your anchors today. I contributed to the budget team along with my colleagues, and my background, I'm from the United States of America, and I grew up in Tennessee, lived in California for a little bit. My background is in environmental policy and planning, as well as GIS, and now I'm a Master of Geotech student. I'm super excited about today's event, and now I will introduce you to my colleague and friend, Carlos. How are you today?
Hi, Gabriel, and hi, everyone. It's good to be here. We would like to give you a very warm welcome to Geomundus 2020. My name is Carlos, and I will be one of the hosts today, together with my colleague, Christian Alejandro. By host, that means that we'll be the persons who will be in charge of muting and unmuting people, managing questions and the Q&A. So if you're facing some technical difficulties, you can use the chat to send us a private message to either me or Christian Alejandro, who's also a panelist, and we'll try to help. So a bit about me, I'm also a geotech student. My background is in statistics, and I'm very interested in the intersection between stats and GIS. This is why I'm so excited about Geomundus, because you'll see that we have many talks about spatial statistics, especially in the field of epidemiology. So this is all for me. Hi, Christian. Would you like to introduce yourself?
Okay, good morning. Thank you, Carlos. My name is Christian Alejandro. Welcome to this 2020 edition of your conference. I am from Mexico, and my background is in geography, urban planning, and also GIS spatial analysis. As Carlos said, we are here to help you and give you support. So we are really happy to be here with you. So let's begin. Thank you.
All right. So to begin this conference, we would like to show you first a short video about the history of Geomundus and how it's developed over the years. Please sit back and enjoy. It'll just be a really quick one.
Geomundus is an international geospatial technologies and sciences conference where we get to share and learn with one another about the importance of spatial data and all things geo. Every year, it gives participants the chance to learn about technological advancements of GI, research activities, and applications in today's world, featuring workshops where participants can experience firsthand the future of the field, as well as career sessions specially designed for students interested in a geospatial career. You may have heard us say this before, but what makes us unique is that this is a conference created for students by students. This is organized by students of the Erasmus Mundus Masters of Science and Geospatial Technologies, with joint participation of Universidad Yame, Universidad Nova de Lisboa, and University of Münster. The idea first came forth from a student named Saraj Karla in 2009, where the conference was held in Lisbon, Portugal. It was so well received, and with the need of management skills in the industry, it was decided to incorporate the event as a part of the graduate program's curriculum. From there on out, the conference location was rotated between the 3 universities each year. As each year passed, students got to put their management and creativity to the test in a real-world environment where the conference has began to gain some attention with growing attendance and notable guests.
Conference that is organized completely by students.
No intervention from the managers, from the coordinators, from the master staff. Gain experience in how the scientific and academic conference are organized.
The conference is actually useful for the students and for those who come, but it also is a good tool to make our master's program more visible to the outside community. So it gives visibility. Many students and other professionals from other parts of Portugal and other parts of the world come to the Geomundus, and they get in contact with the program. So this is actually good. For the students, it's also good because they can start connecting with other people. They can start to build their own networks, academic networks and professional networks for the future, which is a very important part.
Thank you for joining us, and we look forward to sharing our experiences in Geo and learning from yours.
Welcome to Geomundus 2020.
All right, so that was a bit of a background. As you can see, the hosting of this conference is more than a decade of history. And now I'd like to go into the slides explaining the conference itself, just for the opening ceremony. Firstly, as we have said before, it's by students for students, 25 of us in total, really came together to make this work for you guys. 3 partnering universities, University Jaume, University of Münster, and University Nova de Lisboa, which is hosting the first day. And this is the first virtual and 12th edition of this conference.
As you may have realized by now, Geomundus is a conference that is organized by a multicultural committee of young and aspiring professionals and researchers. The attendees of such a conference also come from all over the world, especially this year that the participation is facilitated by the conference being held virtually. So far, more than 270 attendees have enrolled, coming from more than 40 different countries.
Here we have an overview of the conference over the next 2 days. We're going to be sitting with 4 keynote speakers, 3 presentation sessions. We have some of our previous alumni coming to have a bit of a chat with us. Career development session where professionals in the field will come and tell us and answer all our questions. We'll announce our mapathon winners. We have workshops and networking and more. So here is our couple of days. And back to Ian.
A little bit about our advisory board. We began planning for this conference about 6 months ago in May, and the professor presiding over us, kind of looking after us and making sure we were on track, was Dr. Oriol Degbello, who is one of our panelists today. He's here. So thank you very much to Dr. Oriol, and also Dr. Christoph Brox, who's working in the background as well to offer us some advice and insights. Thank you to both of them. And next, I'd like to talk about the sponsors. The sponsors of which for this year's conference were Contera. They are based in Münster, Germany, and they will have a short presentation where they can explain more about what they do. exploring and integrating GeoIT solutions. Many thanks to them for supporting Geo events and this conference in particular.
In case you are not already aware, these are our social media, which of course you can follow. Please feel free to post and share using the relevant hashtags. And keep in mind that the provided QR code points to our Instagram account. Many thanks to the public relations team that has been taking care of them during all this time. And may I remind that the virtually in YouTube for the people that did not manage to enroll on time. And finally, on behalf of all the organizers, I would like to thank especially Dr. Oriol Degbelot for guiding us across these uncharted waters. He has been our mentor during the whole preparation of this conference, and he's here with us today to share some of his thoughts. Please go ahead.
Thank you, FTCR. And morning, everyone. Oriol Degbelot. I am a Privat docent at the Institute for Geoinformatics in Münster. My research interests include geospatial semantics, geovisualization, and smart cities. And on behalf of all faculty members involved in the Master of Science Geotech, it's my great pleasure to welcome you to this 12th edition of Geomundus. We have already seen it in the video that Geomundus is a conference for students, by students. And I would like to quickly stress two key points that to me make Geomundus a particularly nice event to attend. The first point is that Geomundus offers a platform to give feedback to students or younger researchers, and feedback here happens at different levels. We have the scientific level, we will have presentations by students, presentations by senior researchers that are awaiting us. And we also have the career perspective level, because we have presentation from senior professionals, presentation from past students in the alumni session, and we have the career development session, which I guess would provide inspiration and input regarding future career paths. The second point why I think Geomundus is particularly nice is the connection with the GI community more broadly. This is a point where we have been quite successful in past editions with the help of coffee breaks and social events. But we are convinced this year that digital doesn't mean distant, and we want to be, I'd say, at least successful, if not more successful regarding networking this year. So we have prepared some networking sessions where you can get the chance to know others in a bit more personal and less anonymous fashion. So if you have a bit of time, we'll be welcoming you, or we'll be glad to welcome you to these sessions. Finally, I want really to thank very much all the organization team. And with this, I mean the 25 students who put a lot of effort into making this event happen. On behalf of all faculty members, I want to thank you guys for the time you put in, for the creativity, despite the not so optimal conditions, and for the very exciting program that you have prepared for us. Enjoy Geomundus 2020.
Thank you very much for those kind remarks, Dr. Oriol Degbelot. And now we are about to move on to the first keynote presentation of today. But first, I'd like to go through the keynote speakers. Today's keynote speakers are Dr. Paula Moraga, who is presenting right now, and Dr. Linda Beal, who will be later on in the afternoon. The following two presenters will be in day 2, so stay tuned and stay around for tomorrow's events and programs. Under our very first keynote presentation, day 1, starting at 10:15 CET, I would like to welcome Dr. Paula Moraga. She is going to be talking about geospatial data science for public health surveillance, a topic that really concerns the welfare of us all today. And I'm wondering if she is actually present in the panelist list. Let me give a quick check. She is, okay. Welcome, Dr. Moraga. Hope it's a bright and sunny day for you like it is for us in Lisbon. So a quick intro about Dr. Moraga. She is an assistant professor of statistics at KAUST University in Saudi Arabia, and also the principal investigator of geospatial statistics and health surveillance research group. Her research focuses on the development of innovative statistical methods and computational tools for geospatial data analysis and health surveillance, the results of which have influenced strategic policy regarding disease response in several countries. She has also developed modeling architectures to understand the spatial and spatio-temporal patterns for intervention of diseases, such as malaria in Africa, leptospirosis in Brazil, and cancer in Australia. She has also worked on a number of R packages, developing them for Bayesian risk modeling and detection of disease clusters, as well as risk assessment of travel-related spread of disease, something which is extremely relevant to everyone right now under our current pandemic scenario. So please, Dr. Moraga, if you will, I will stop sharing so that you can share your screen.
Well, thank you very much for this introduction, and thank you very much for the invitation. It's a pleasure to be here and be able to talk about my research. And also I'm looking forward to see the rest of the talks and sessions that you have prepared for this great conference. So today I'm going to give an overview about geospatial data science for public health surveillance. My name is Paula Moraga, and I'm an assistant professor of statistics at King Abdullah University of Science and Technology, known as KAUST, in Saudi Arabia. And I'm the principal investigator of the GeoHealth research group. My research focuses on the development of statistical methods and computational tools for geospatial data analysis and health surveillance. I have developed methods to understand the spatial and spatiotemporal patterns and identifying risk factors of diseases such as malaria in Africa, leptospirosis in Brazil, and cancer in Australia. I also develop a statistical software for reproducible research and communication, and I'm the author of several statistical packages for Bayesian disease mapping, detection of clusters, and risk assessment of travel-related spread of disease. And I'm the author of the book, Geospatial Health Data, Modeling and Visualization with ARILA and Shiny. This book is published by CRC, and it's also freely available online, and it covers how to manipulate and transform spatial data and how to create maps using R. It also shows how to fit and interpret spatial and spatiotemporal models with INLA and SPDE, and how to create interactive visualizations, reproducible reports, dashboards, and Shiny web applications that facilitate the communication with collaborators and policymakers. The book focuses on health examples, but the methods covered are useful to analyze spatial data in any other disciplines such as ecology, the environment, or criminology. So today I'm going to give an overview of my research in geospatial data science for health surveillance. First, I will talk about geospatial data and methods. Then I will talk about 2 case studies in tropical disease mapping. And after that, I will talk about statistical software. And finally, I will tell you a little bit about my current research. So I'm going to start by showing this map. I'm sure many of you know that this is John Snow map of cholera. So this map was created in year 1854 in London, In that year, there was an outbreak of cholera, and people didn't know how it occurred because they didn't know how cholera was transmitted. So Dr. John Snow mapped the deaths, and he found out that all deaths were clustered around a water pump in Broad Street. So he convinced the authorities to remove the water pump, and when they did that, the outbreak disappeared. So this is one of the first examples of the importance of geospatial methods for health surveillance. These methods can be used for understanding geographic and temporal patterns, highlight areas of high risk, measure inequalities, and the early detection of disease outbreaks. The results of this analysis can be communicated using maps and other visualizations, and these results guide decision makers to better allocate limited resources and to design strategies for disease prevention and control. And as I said before, many of these methods that we use in surveillance are also useful to analyze spatial data in other disciplines. In spatial epidemiology, we divide data in 3 types: aerial data, geostatistical data, and point patterns. In aerial data, we have a region of a study that is divided in several sub-areas. And in each of these small areas, we know the number of cases, the population, risk factors, and our objective is to estimate the risk in the areas. In geostatistical data, we assume that the risk is a spatially continuous surface, and we can measure the risk at the specific locations. And the objective here is to predict the risk in areas that are not sampled. And in point patterns, the data are the locations of people with disease. For example, this is the city of Valencia in Spain, and all the dots represent the locations where people with kidney disease live. And it's the same as here, where the dots represent the locations of people that died from cholera. So the objective in point patterns is to understand what is the process that originates this data. Is this data random? Are they clustered? Are they close to a contamination source? So, for example, if we work with aerial data, as I said before, we have the region of a study partitioned in small areas, and we want to estimate the risk in each of the areas. One thing that we can do is to calculate the standardized mortality ratio. And this is the number of cases observed divided the number of cases expected in each of the areas. So if we have that this ratio is greater than 1, we have more cases observed than expected. So this means that this is a high risk area. And if SMR is less than 1, we have less cases observed than expected. So this is a low risk area. So this is very easy to calculate, but it may be misleading and unreliable in areas with small populations or rare diseases. For example, imagine that we have an area with a very small population and we have 0 cases. In that case, SMR would be 0. We will say that the risk is 0, which is not true. Or if we observe 1 or 2 cases, we will get a very extreme value of risk that is also misleading. So instead of calculating this SMR, what we do is to use models that enable to incorporate covariates and to borrow information from neighboring areas to obtain smooth relative risks. So we can use models like this. Here we say that conditional on the relative risk of area I, the number of cases in area I follows a Poisson distribution with mean. The expected counts times the risk. And then we say that the logarithm of the risk is equal to some covariates plus random effects. So the fixed effects part of the model quantify the effects of the covariates on the disease risk. And the random effects represent residual variation that cannot be explained by the covariates. So there will be other information that we haven't put in the model. We cannot measure other covariates, or we don't know about other covariates that influence the risk. And all of that variability will be in the random effects. And we can put, for example, a spatial random effect to acknowledge that areas that are close to each other have similar risk. And we can also put a random effect without any structure to acknowledge that although two areas may be close to each other, may have different risk. In geostatistical data, we assume that the risk is a spatially continuous process that we can measure at specific locations. So for example, here we have the map of sub-Saharan Africa, and these points represent the prevalence of lymphatic filariasis in each of these locations. So in each of these locations, there was a survey that collected information about N people, and out of these N people, they made a test, and some of them were positive for the disease, some of them were negative for the disease, and the prevalence is the ratio between the positive and the total number of people in the sample. So here we can see that some locations have low prevalence, other locations have higher prevalence. So we have an idea of the disease burden, but we don't know anything about what is the disease risk in areas that are not sampled. So what we want is to develop a model that allows us to obtain a spatially continuous surface of the disease risk that can be useful to understand what is the disease level at the local level. And we can use a model like this. So at each of the locations, Xi, there is a survey with Ni people, and out of Ni people, Yi are positive. So this is a binomial distribution. Conditional on the true prevalence at location Xi, the number of people that tested positive is binomial distributed with parameters Ni, that is the number of people in the sample, and the prevalence, that is the probability of being with the disease. And then the logit of the prevalence can be expressed as a sum of covariates plus random effects. And again, in the covariates, we will put characteristics known to affect disease transmission. Maybe the disease is affected by temperature, precipitation, elevation, and so on. And then we also put random effects to model variation that cannot be explained by the covariates. So there will be other factors that we don't know that will be affecting the disease, and all of this variability will be modeled with the spatial and structured random effects. And finally, in point patterns, we have that the locations, like the data represent locations of people with disease. And what we do is to assume that this is a point pattern that has been generated as a realization of a point process. And we want to understand what is this process. So we want to understand the distribution of the locations. We want to estimate the intensity of events and learn about the correlation between the locations and spatial covariates. So now I'm going to show you two case studies where we use geospatial models for tropical disease mapping. One of them is modeling of lymphatic filariasis in sub-Saharan Africa, and the other is modeling of leptospirosis in Brazil. So lymphatic filariasis is a disease caused by microscopic worms and transmitted by mosquitoes. So when the mosquito bites the person, the worms go to the lymphatic system, and there they cause blockages that cause swelling of the arms, the legs, and also thick and hard skin. So this is a very painful disease. People with this disease are rejected by those in their communities, and this causes a lot of suffering and poverty. Lymphatic filariasis affects tropical and subtropical regions of the world, such as Asia, Sub-Saharan Africa, and also parts of the Caribbean and South America. And the main strategy against the disease is mass drug administration, which is recommended to populations in regions where prevalence exceeds 1% annually for at least 5 years. So ideally, we would give the drugs to everyone that needs them, but in reality, resources are limited and we need to decide which are the areas most in need. In this study, we wanted to predict lymphatic filariasis prevalence in Sub-Saharan Africa. We had 3,197 surveys, and here you can see that we can see that there are locations with low prevalence, other locations with higher prevalence, but as I said before, we don't know what's happening in areas where we don't have data, and what we're going to do is to predict prevalence in areas that are not sampled, so decision makers can have a map to inform their decisions. So I'm going so what we did is to use this model that I have explained. And in the model, we put covariates such as precipitation, vegetation, elevation, land cover, population density, because this is a vector-borne disease. So we know that mosquitoes like humid places. And we also know about other risk factors such as population density or poor areas. Finally, these are the results. So we are able to get this map that shows the predicted prevalence. We have that there is higher prevalence in the east coast of Africa, east coast of Madagascar, also in pockets in the west, and we have lower prevalence in Ethiopia and in the center of Africa. We also computed maps representing the lower and upper limits of 95% credible intervals, denoting the uncertainty of these predictions. And these maps can help surveillance activities because they allow us to identify areas that require enhanced interventions, and they are also useful for setting a benchmark for evaluating the impact of interventions. In the second study, we studied leptospirosis in Brazil. This is a disease transmitted by the urine of the rats or an environment that is contaminated by the urine of the rats. And it's an urban health problem due to the rapid and disorganized expansion of urban centers that creates ecological conditions for rat-borne transmission. In this study, we assessed leptospirosis in Pau da Lima. Pau da Lima is an urban slum community in Salvador de Bahia in Brazil with a high annual incidence of leptospirosis. So here you can see that households are at different elevations. There is a lot of vegetation, accumulated trash, open sewers. And people carry out risk activities such as being in contact with mud and water that can be contaminated. So here the objective was to understand the spatiotemporal patterns of leptospirosis and identify targets for intervention. So we recruited 2003 subjects and followed them for a 4-year period. And each year, we administered questionnaires and GIS mapping to determine social, behavioral, and environmental risk factors. Then we fitted a spatiotemporal model. We used some of this information. These are the variables that we collected. We have demographic and social status factors such as gender, age, being literate, health factors such as diagnosed with dengue, occupational exposure such as working in Pau de Lima, household environment such as elevation of the household and work behavior, and household and work reservoirs such as observing rats near house or near job. So we have all of these variables, and then we selected some of them to be in the model. And to do that, we followed a backward elimination procedure. And finally, these are the variables that we selected. We have year follow-up that can be first, second, third, or fourth year, gender, being literate, house elevation, observing rats near house, contact with mud near house, and a non-linear effect of age that we model with a piecewise linear function with break at 20 years. So these are the results. So here we saw that the risk of leptospirosis was higher in year 4 compared to year 1, and lower in year 3 compared to year 1. We also saw that risk factors were being made, being illiterate, observing rats near home, and contact with mud near home. And we also saw a non-linear effect of age, like the risk of leptospirosis increased with age until 20 years, and then it was more or less constant. And this makes sense because young people have more risk activities, such as being in contact with mud and water that can be contaminated. These maps show the areas with the highest in red and lowest in blue odds of infection. We see that the maps are consistent over time. Highest risk areas are in the lower part of the valleys where the sanitation conditions are worse and there is a lot of vegetation. And the lowest odds of infection are in the upper parts of the valleys where the sanitation conditions are better and also the households are close to a main road. We also examined the residuals because we wanted to identify locations where the risk was higher or lower than predicted by the risk factors. So this is a location with residual 0. So this is a location in which the risk is consistent with prediction. And here we have accumulated trash, a lot of vegetation, open sewers, and rats can be seen very easily. This is a location with high positive residual. So, and this is a location, so the risk is higher than predicted by the risk factors. And this is because there is poor household construction and there is flood risk due to poor infrastructure. And finally, these are locations with high negative residual. So the risk is lower than predicted by the risk factors. And this is because there are open sewers that increase the risk, but these sewers have barriers to stop overflow. So the risk decreases. So to conclude, we saw that young adults, males, and individuals with low social status may have higher risk, and that interventions such as providing sanitation systems may reduce the burden of leptospirosis in the community. So now I'm going to talk about a statistical software. So I also develop software so my methods can be widely available and provide benefits beyond my own applications. I'm the author of a Spatial AP app, and this is a Shiny web application for disease risk estimation, cluster detection, and interactive visualization. So here the user can upload the data, can upload the map, and by clicking some buttons, they can obtain risk estimates by fitting Bayesian models with ILA, and they can also detect clusters using StatScan, and they can also visualize the results in an interactive way and generate reports. I'm also co-author of a package called EpiFlows for risk assessment of travel-related spread of disease. And this is a package that implements a mathematical model to predict the number of cases that could be spread to other locations from an infectious location together with uncertainty measures. And this is a model that integrates information about the number of infectious cases, population flows, lengths of stay, and information about the disease. To calculate the total number of infections, the model calculates the exportations and the importations. The exportations are people that are infectious, that live in the infectious location, get infected, and then go abroad and can infect people abroad. And importations are people that come to the infectious location for holidays, for example, get infected, and then when they return to their home countries, they infect people in their home countries. So the total infections are calculated by adding up exportations and importations, and the uncertainty is obtained by sampling from the incubation and infectious period distributions. I'm also part of the R Epidemics Consortium, RECON. This is an organization gathering experts in data science, modeling, public health, and software development to create the next generation of tools for disease outbreak response. The EpiFlows package is part of RECON, and there are many other packages for manipulation, analysis, and visualization of spatial data, epidemics data. I'm also part of the AfriMap-R project, and this is a project where we want to create R tools to facilitate the use of spatial data in Africa. This project started in January, so far we have been focused on research that can be useful for COVID-19 response. And some of the members of the project developed this shiny app that is useful to map health sites and is useful for planning. Now I'm going to tell you a little bit about my current research. I recently joined KAUST, and I'm excited about continuing working on statistical methods and tools to solve challenging problems and improve population health. I'm very interested in precision disease mapping. Disease maps are very important to understand the spatial and spatiotemporal patterns of disease, identifying risk factors. And often these maps are given at an aerial resolution, such as municipalities or counties. This, for example, is a map that shows malaria prevalence in Mozambique. So here we can see that in the north, prevalence is higher than in the south. But this is not very useful for decision making because we don't know how risk varies within areas. So what I'm doing now is to develop statistical methods to disaggregate area level data, so we can from area level data we can compute high resolution estimates of the disease risk, where we can see the variation within areas, and this is much useful for decision makers because they are able to identify locations of high and low risk in a given area. Also, I'm very interested in digital epidemiology. Disease surveillance systems are critical for the early detection of epidemics and the design of control strategies. But the information of surveillance systems, of traditional surveillance systems, is delayed. From the time that the person gets sick to the time that the person decides to go to the doctor, goes to the doctor, have the laboratory tests, and that information is in the system, it may take a few weeks. So this information is not useful for taking action in real time. Nowadays, we have access to other types of information, such as social media posts, where people chat about how they feel, or Google searches, where people search information about treatments for their conditions. This information is not produced for epidemiological research, but we can use it to understand disease activity levels in real time. We also have access to demographic and environmental risk factors that may affect diseases such as temperature, humidity, rainfall. And my objective is to develop a digital health surveillance system that integrates multiple data sources to produce local probabilistic predictions of disease activity in real time, and that can inform public health officials when elevated disease levels are anticipated. I'm also very interested in the development of interactive visualization applications for policymaking. Effective communication and proper and timely dissemination of information is essential for the development and implementation of population health policies. And I'm working in the development of digital health atlases of cancer and other diseases, and also in the development of surveillance system to monitor diseases in real time. So before finishing, I wanted to say that I recently joined KAUST, and I'm looking for outstanding PhD students and postdocs to join my group. So if you're excited about geospatial data analysis, applications in health and the environment, and the development of R packages, and are interested in joining the group, please get in touch. KAUST offers an excellent research environment, free tuition, monthly living allowance, free housing, and is an excellent university to study and research. These are some references, the Geospatial Health Data book, and also other references about papers in statistics and surveillance. And that's it. Thank you very much.
Thank you very much, Dr. Polemarga. A virtual round of applause, please, from everyone. You can spam our chat with some clappy hand emojis if you'd like. Yeah, thanks so much. I believe there are some questions from the audience for Dr. Polemarga. If Carlos would like to handle this.
Yes, absolutely. First, I want to thank Dr. Polemarga because, as I explained before, my background is in statistics, and as I have worked as a biostatistician, I have used the Bizarre-Georg-Molly model many times for disease mapping using Winbacks, though, so I'm really excited about the ILD approach, and also how to use the ILD approach to map using geostatistical data. This is something new for me, so I'm very excited. I have questions of myself, but of course, attendees are a priority. So I will start with a question that we have from Aswi from the Nigeria, Makassar, Indonesia. Actually, this attendee has two questions. The first one is, why did you use binomial distribution in geostatistical models? Have you tried other models such as Poisson distribution? Are the results different?
So in your statistical model, so I use binomial distribution because it depends on the data you have. Like, where it is. So in my case, I have data from surveys. And like in each of the villages, there was a survey where people was recruited Like there was, for example, 100 people that came to do a test to see if they had the disease or not. And some of them were positive and some of them were negative. So we can assume that the probability of being positive in that village is Pxi. So in that village, with a probability P, one person will be positive, and with a probability 1 minus P, one person will be negative for the disease. And if you think about distributions that can be adapted to this problem, you see that this is a binomial distribution. In the binomial distribution, you have a set of objects or a set of people. Here is Ni, and the probability of having a positive result is P, and here is the prevalence. And this is why we use the binomial distribution.
Yeah, I think it makes perfect sense. And also it explains why we use Poisson when we have aerial data, because we have the counts of the aerial of the unit. So it makes total sense. Thank you very much. There's a second question from this attendee, but in order to give everyone a chance, we have a speaker, an attendee who has raised her hand, or his hand. It's Ayman Nobswat, and I will allow you to talk, and you can pose your question live. Now you can do it. So we have no input from Ayman now, but feel free to ask a question later. So we will follow by a question by Julia Melissa, which says, I found the second study case very interesting. Also, I did. Thank you for that, Dr. Paula. I have a question. After data collection survey, how did you decide which data to use or to exclude for pre-processing for proceeding with the analysis? I think that she is mentioning the covariate selection.
In the covariate selection, okay. So here in the study in Brazil, we had like a lot of information that people working in the field in Brazil collected, and like at the beginning, epidemiologists and people that knew the area and knew the disease thought about what were the possible risk factors, and they collected all of this information. So in our model, what we want is a model that is simple, because we want to interpret the effect of the covariates, because we want to have an interpretation of this model, because later we want to develop interventions to decrease the risk of leptospirosis. So we cannot put all of these covariates in the model, because there will be like a lot of correlation in the covariates, and we would not see what is the effect or anything. So we need to decide which of them are better to predict the risk. So what we did is, like, we have grouped the covariates in 8 groups, like all the covariates related to demographic and social status factors were in one group, all the covariates related in health factors were in another group, all the covariates in occupational exposures were in another group. And after that, we selected some of the covariates in each of the groups, like some of the covariates in the first group, some of the covariates in the second group. And the way to do that is what we did, there are several approaches that you can follow, but what we did was to fit a generalized additive model using all the categorical variables, non-linear effects of the continuous variables, and interactions between them. We fitted a model with all the covariates in each of the groups, and then we follow a backward elimination approach, where we started to remove covariates one by one until obtaining a model with minimum ASC. So we have in each of the groups some covariates. Then we put all the covariates together and did the same. We follow an approach to remove covariates one by one until it was no longer possible to reduce the AC. And finally, we came up with this set of covariates to put in the model.
Thank you for this detailed answer. Yeah, I agree. I think that collinearity in such multivariate analysis is always an issue. And we have another question from Atsuyasu related to COVID. And I think that this question got many upvotes, so this is relevant for everyone. He or she says, could you apply your method to predict when will the COVID-19 peak will occur and end?
Well, so unfortunately, no, because so if you see the types of diseases that I'm showing, these are diseases that are driven by environmental, climatic variables. So they depend a lot about the location. But COVID-19 is spread like by contact with people that are infected or contact with a contaminated surface. Mobility and contact with other people plays a big role. So if, like we have seen, the interventions such as lockdowns and social distancing measures are the interventions that are doing that the pandemic and the curve decreased. And these are the drivers of the COVID-19. So for analyzing COVID-19, so it's better to use mechanistic models that partition the population in susceptible, infectious, and recovered, and then using a set of differential equations, we can understand what is the movement between each of the compartments, or we can also use network models to understand how mobility and how contact is going to affect the evolution of COVID-19.
Thank you very much for your reply. And then, yes, unfortunately, you cannot use these models, but there are many mathematicians, statisticians working on that. We have time for one quick last question, and this comes from our dearest mentor, Dr. Oriol Degelo. It's about the SMR. He asks if we could use the SMR to critically assess the COVID situation rather than metrics based on new infections alone. I wonder what's your view on that?
So the thing with COVID-19 data is that so we have a number of people that are infected. This is what is reported, but we know that there are many more people that are infected, but they don't have symptoms. So we are not able to detect all the infections. Also, sometimes people have the tests, they tested negative, but they're incubating the disease. So there is a delay from that time that the person gets sick to the time that the infection can be detected using a test. So there are a lot of biases. So if we go to the public health departments, we download data about infections and we do this ratio, this is not correct, because the data that are collecting them are about people that had the test, they were positive, but this is incomplete. There are many other people with COVID-19, and there are approaches to estimate the real number of infections. So it's not enough doing this ratio.
Yeah, thank you so much. Yeah, we've been experiencing in the last months how many biases and potential issues COVID data may have. So this was a very relative question and answer. Thank you. I think we're out of time. So I would like to ask a final round of applause and a warm thank you to Dr. Paula Moraga for being able to join us today and give this amazing talk. So thank you so much. And I think that Ian, we can move on to the next session. Thank you again, Dr.
Thank you
Paul.
very much. Thank you.
Goodbye.
Bye.
I'm muted. I'm talking to myself because I was muted. That was an interesting talk. Thank you very much. We're going to be rolling swiftly on to the first presentation session. Let me first show you my screen. So, the first presentation session, we actually asked for paper submissions from the world, really, and we received 21 in total. Many levels of research and academia submitted papers, and we are going to start with our first paper, which is titled Effective Radio Frequency Planning for 5G, a Spatial Decision Support System, SDSS, and this is a presentation by Abhishek Pandey from India. I believe he's already in the panelists group, and if we could promote him and then enable him to share screen. Let me stop sharing screen. Abhishek, are you there?
Yeah, hi.
Hey, how are you doing?
I'm doing good.
Perfect. Can you try to share your screen? Do you have those permissions? Awesome. All right. Then the floor is all yours.
Thank you. Hello and good morning, everyone. My name is Abhishek Pandey, and I am a recent postgraduate geoinformatics student from TERI, the only deemed to be university in India dedicated to building capacity in sustainable development. Today, I'm going to present my paper on the topic Effective Radio Frequency Planning for 5G Spatial Decision Support System, completed under the guidance and mentorship of Mr. Dikshant Saxena, Dr. Neeti, and Ms. Sijuti Sen. The study was carried out in a span of 4 months while I was intern with Air Technologies, the world's #1 location platform company. So what is the first thing that comes to our mind when we say 5G? It's speed and in rate of Gbps, that too wirelessly. Actually, 5G is more than that. It promises network reliability, low latency, and support for more devices and connection to various IoT sensors. But the enigma of 5G is that higher frequencies, which are supposed to carry massive amount of data, have a very short range which can be obstructed by small objects. Hence, accurate spatial and location information is absolutely necessary. So how do we overcome this problem? The answer is with the help of a digital twin. A digital twin consists of various geodata such as clutter or land cover, 3D buildings, tree canopy, etc. But before moving to geodata and digital twin, let's quickly look into the 5G bands and see how they interact. The low band and mid band of 5G spectrum can be upgraded on existing infrastructure and have a vast range, reach, and bandwidth, but they have limited data transfer speed. The high band, on the other hand, requires new infrastructure, that is small cell infrastructure. It has super fast speed and data transfer capabilities, but it cannot penetrate through obstacles. So basically, it requires cell densification. Let's check out this visualization for a better understanding. The high band is not able to penetrate obstacles, but has fast speed with very less latency. The mid band has a balance between speed and range, but has limited indoor bandwidth. The low band is a bull, not affected by obstacles, but has exponentially less speed and data transfer capability. Coming back to digital twin and geodata, with the help of spatial informatics, RF engineers get to know about 4 major things: cell site candidates, how to effectively map line of sight, where to place RF equipments or what are the suitable sites, and the overall coverage. Hence, a methodology has been proposed to create high-resolution geodata, which are required for radio frequency planning. The aim of the study is to investigate how field of spatial informatics can be applied to 5G radio frequency planning. The objectives include creation of geodata required for 5G, which are clutter, 3D building, digital terrain model, and 3D canopy mesh or 3D canopy model. The second objective is to identify potential locations for 5G poles or antenna installation and carry out line of sight and viewshed propagation analysis using digital twin and further converting it into a web tool. The methodology was as follows. The worldview imagery with a resampled resolution of 50 centimeters was used for classification using SVM technique and Maryland classification scheme in order to produce the clutter or land cover. 2D building footprint obtained from hair database were converted into 3D polygons and further into a 3D multipatch using ArcGIS model maker and various archive scripts. Terrestrial mobile LiDAR data was segmented and classified using PointCNN, a deep learning module present in ArcGIS API for Python. From the segmented LiDAR, canopy was extracted, and with the help of Autodesk Recap, the canopy was converted into mesh. Euclidean distance was calculated for road and pole layer and used along with created geodata for site suitability. For site suitability, AHP, a MCDA model developed by Thomas Sathi, was used to identify suitable site. Once the suitable sites were identified, they were together used with geodata to create a digital twin and a web map, and further created to create a web map where line of sight and coverage analysis can be carried out. The results obtained for clutter. The accuracy achieved was 87% and the kappa coefficient was 0.8 using SVM classification technique. The total study area of central Bengaluru was 70 hectares or 0.7 square kilometer, where open in urban and open land covered 2.5 and 2.6% of the total area and vegetation covered 29.2% of the area. 3D buildings. The multi-patch buildings obtained had a vertical accuracy of 50 centimeter. ArcPy scripts and ArcGIS model maker was used for automatic conversion of 2D buildings to 3D multi-patch. 3D buildings and clutter altogether elevates RF planning from being theoretical to physical. Canopy. PointCNN was used for LiDAR classification and segmentation, and it produced an overall accuracy of 95.2%. For canopy class, the precision was 98.3 and recall was 96%, which meant that only 1.7% of the canopy did not lie in the actual real canopy, and only 4% of true canopy was missing. Canopy mesh was created using Autodesk Recap and then imported as a multi-patch in ArcGIS. Digital terrain model. Terrain model is the basic and indispensable data input for radio propagation studies and planning, as the terrain blocks and reflects radio waves based on the bare earth relief feature. Since point spacing of the LiDAR data was 0.034 centimeter, binning interpolation with linear void fill method and cell assignment type as IDW was used to fill any gap or void present. The achieved resolution was 1 meter. This is the overall look of the digital twin that was obtained. The green is the vegetation, the blue is TTM, and the gray textured are the 3D buildings. Suitability. Major steps involved for AHP are assigning the hierarchical structure, identifying and ranking the relative weight for the criteria and sub-criteria, determining weight for each alternative, and measuring the final score. The weights obtained from pairwise matrix were 41% for building elevation, 23% for TTM, 12.5% each for distance to road and distance to pole. Clutter had a weightage of 5.3 and canopy had a weightage of 4.5%. Since our consistency ratio was 6%, the weights calculated were finally used in the AHP. Using the AHP model, from the obtained map, we got to know that 1% or 0.73 hectare of the area was considered to be very highly suitable. And these locations were further extracted using polygon to point conversion tool, which gave us 90 locations. These are the highly suitable locations. Here is a video which shows line of sight and coverage analysis carried out. The green line depicts clear line of sight, while the magenta line depicts obstructed line of sight. For view shed analysis, green area represents clear view, magenta area is obstructed view, and the yellow area shows clear and common area from two different views. We can also see the difference canopy makes. And this is the overall view of 3D web map having the raster layer. It is currently in development, and soon it will also have the line of sight and coverage analysis within itself. To conclude, a generalized and scalable model of geodata with high resolution and accuracy was obtained, which can be applied to radio frequency and smart city development theme. The digital twin used to locate suitable zone and effectively mark line of sight is basically used to fine tune the best possible location along with maximum coverage. The digital twin also optimizes the time and cost by reducing the number of ground surveys and manpower required to do so. On-the-go visualization is prioritized using geodata for our 5G RF deployment, as a person or a RF engineer with a laptop or tablet can easily view the area and do preliminary analysis before reaching a final decision. Let's look at some of the limitations and future scope of the study. Capacity building data, that is called ROPS data, is currently not included in the MCDA, but can help in identifying dark spots or area with very less coverage. Various other MCDA techniques or machine learning techniques, such as artificial neural network, can be utilized for site selection and also to compare the results. A more detailed multi-patch, such as one having floor information and building material, can be utilized for analysis. This will help in knowing the actual annotation factor. The geodata model is not limited to RF, that is radio frequency, and can help in maintaining and planning of infrastructure, creating a tree inventory as well as for disaster management, etc. So with this, we have reached the end of the presentation, and I'm grateful that I got this opportunity to present in front of this amazing audience. And thank you, Geomundus. Thank you to everyone involved in this study. I'm now open to questions and comments.
Thank you. A round of applause for you, Mr. Pandey. That was an amazing talk.
Thank you.
Do we have any questions? I believe we do. Carlos?
Yes, we do. Julia Molise was very impressed by your visualizations in the presentation. I think that here in Lisbon headquarters, we all said, wow, when we saw your beautiful 3D maps. Julia Molise asks, namely, probably you mentioned this, but what software did you use for visualization in your work?
For visualization, we have used ArcGIS Pro, and for creating the 3D web pack or the web tool, we are currently using ArcGIS, JavaScript, and ArcScene. So basically, web builder.
Okay, thank you. We have two more questions. First is by Mateen Mahmoud, one of our dear colleagues. Hi, Abhishek. It was good to see nice presentation. I have a query. In my opinion, weights are crucial when applying MCDA and affects the final output. For the factors to be considered and their relative importance, how did you determine them? And we have mostly the same question by another attendee.
Yeah, so basically, while planning of 5G, elevation is one of the crucial factors. So for DTM, we have considered elevation. For building also, we have considered elevation. And for canopy, so elevation is also the factor in the canopy. But in building and DTM, the higher would be the elevation, the better would be the result. But in terms of canopy, the lower or the smaller the value of the height of the canopy would be present, the better would be the result. And also in like future scope, one of the other considering factor could be also the material used in the buildings.
I see. Thank you so much for your detailed answer. And I think we run out of time. So back to Ian. Thank you very much for your presentation. It was great. Thank you to have you here.
Thank you again. Thank you, Carl.
Bye.
Thanks. All right, so back to me. I am sharing my screen. One thing to keep in mind is that many of our presenters, keynote speakers, and panelists will still be available for network sessions, etc. If you're curious about whether they'll be available for anything, just ask in chat. I think they can see it. Make sure that you're chatting to everyone, not just to individual people, if you're trying not to do that. But anyway, now we're moving on to the second presentation session of today, which is titled Wind Energy Assessment in Costa Rica using Multi-Criteria Evaluation. This was a paper submitted by Alba Villanova Cortizon, who is, I believe, one of the first years in our Geotech Masters. Also, interestingly enough, this is one of the papers that managed to scoop the Best Paper Awards. It was one of the top papers that we actually reviewed. And we reviewed a total of 21, by the way. So well done. Alba, Ms. Cortizon, are you here?
Yes, I'm here. Can you hear me?
Yes, I can hear you. I'm going to stop sharing my screen and let you do so.
Okay. Wait. Can I? Okay.
Awesome. Yeah.
Okay, perfect.
Right.
Good morning to all. My name is Alba, and first of all, I want to thank the Geomundus organizers for this conference. Today, I'm going to present my study on the evaluation of the wind energy potential of Costa Rica using a GIS-based multi-criteria evaluation in order to know which are the best locations to install wind farms around the country. Although I'm from Spain, I decided to study, to make this study in Costa Rica because it's going to be the first country to become decarbonized in the whole world, as it was announced in 2018 by the government. And the main sources of energy that they want to use and that they are using are hydroelectricity and wind energy. As we can see in the schema in this table, nowadays, last year, hydroelectricity accounted for 70% of the total wind power generation, and wind energy accounted for 60% of the energy production. The thing is that seeing the current trends in economics, we can see that the wind energy prices are predicted to decrease, but the hydroelectricity prices are going to stay stagnant. And for this reason, I thought that it would be interesting to know which are the most suitable areas to install wind farms to substitute the 1% of energy that is currently coming from non-renewable sources, specifically from thermal energy. The plan that I mentioned before, it's called Plan Nacional de Descarbonización, and it's supposed to be finished by 2050. In order to do the multi-criteria evaluation, I needed to select which criteria I wanted to consider. The main one, the most important one, it was obviously the wind speed, because it contributes to the wind potential, the wind energy potential. And here we can see the data sources, the format and the resolution that I used from the data that I could get. Another criteria was elevation, and more specifically the slope, because it is very important for construction, for the construction and the maintenance of the power plant. Also the land cover, because there are areas where we cannot install wind farms. The distance to transmission lines networks and to the roads. Also the location of the protected areas, because they need to be excluded. And in Costa Rica, they account for the 25% of the country. And also the population density, because wind farms are quite noisy, and we want to locate them far away from the people. The weights that I considered, and the suitability scores are presented in this table. First of all, I wanted to consider the wind speed as the main factor, so I gave it a weight of 3, which is the maximum. Then I considered the population density to be the least relevant factor for this study, and then the other ones have the same weight. These weights and the suitability scores were obtained from several research. For instance, about the suitability scores, we have that the most suitable area to locate a wind farm would be the areas that have a wind speed, an average wind speed superior to 7.5 meters per second, a slope of a maximum 7.5 degrees. It would be located in cropland, or also in vegetation actually, and it would be a maximum 5 kilometers from the transmission lines and at 1 kilometer from the roads. And the population density would be of maximum 50 people per square kilometer. Regarding the methodology, the first thing I had to do was to reclassify all the layers. And there were some that I had to do some other steps before. For instance, for the slope, I had to extract it from the elevation model. And for the transmission lines network and the roads network, I had to calculate the Euclidean distance to know to get it at every point in the map. And once I combined all the layers according to the weights, I had to remove some areas, as for instance the protected areas, and also I had to buffer the roads network, the urban water bodies and wetlands, and also the transmission lines network, in order to be a bit away from them. Because although it's good to be near the roads for construction, it's better to be not so close to them. So I considered a distance of 100 meters for the roads, 500 meters for the transmission lines, and 100 meters also for the urban water bodies and wetlands. Here we have some of the results. The first map is about the wind speed. We can see that the areas with highest wind speed, superior to 7.5 meters per second in average, are located in the northwest of the country, which is quite interesting because the mountainous areas of Costa Rica are actually in the south. As we can see here, this is a map of the slope, so it's derived from the digital elevation model. And we already can see that the south of the country is going to be unsuitable for wind farm development. Also, here we have a map of the land cover. We can see that a big part of the country is covered by forests and also by cropland. And only, the croplands are going to be the areas where it was going to be better to install wind farms, as I said before. So we can already say that the orange and red areas are going to be not great for this. Then here we have the population density, and we can see that that almost all the country is suitable for wind farm development, except the center, where San Jose, the capital, is located, and also its surrounding areas. It's not possible to install here because the population density is superior to 500 people per square kilometer. Here we have the reclassified Euclidean distance of the road networks. And here we have the reclassified distances, Euclidean distance from the transmission lines and CEPAC. CEPAC is the electric line that connects all Central America. And I had to consider it for this study because it provides energy to Costa Rica. The final map that I obtained was this one. So as we can see, the northwest of the country is the region with the highest suitability for wind farm development, and it's also the place where most wind farms of existing wind farms are currently installed. We can also see that a big part of the country is covered by protected areas, which are mostly the black and unsuitable regions. And the unsuitable regions actually account for 37% of the country. The high suitability areas are quite low, actually, only 3%, which equals to 1,500 square kilometers approximately. And then we also have lots of medium suitability areas, which could be also useful, but it will be more convenient to install in this greener, dark green area. And then I also wanted to note that the highest suitability areas are located in Tilaran, which is this place I would like to point, but I can't. This place here in the northwest, where we can see that there are many wind farms. As the conclusions of this study were that at least 16,000 square kilometers are moderately and highly suitable for wind farm development, and almost 38% is unsuitable. But this is due to the fact that 25% of the area is actually protected, and there are national parks there in most of the cases. Also, I could conclude that Tilaran, Cañas, and Bagaces were the best cantons, which are the provinces of Costa Rica, to produce wind energy. And finally, I wanted to mention that the study is limited because there are many other criteria that should be considered, such as the distance to the railways and the location of the airports, the mining sites, also the historical and archaeological areas. Also, I think that the data that they obtained could have higher spatial resolution, and then the study would be better. But well, yeah. That's it. Thank you for listening, and if you have any question, I will be here to reply.
Thank you very much, applause from our headquarters in Lisbon, and virtual applause, please. Thank you, guys. Thank you to you for your beautiful presentation. Renewable energy is something that's really interesting to me, and I'm sure a lot of people. Climate change is one of our pressing issues. If we didn't have the pandemic, it's one of the things we'd be talking about the most. Yeah, I believe there might be a question.
Yes, we have one question from one of our anchors, actually. So, Eftihia, if you want to ask your question live.
Yes, sure. Well, I would like to ask, first of all, thank you for your presentation and congratulations for the prize won. And I would like to ask if you know what is the main land cover class for the suitable areas?
The most suitable areas considering the land cover, you mean?
Yes, yes.
So they are croplands and basically vegetation areas that they are not owned by anyone, but that's a very little part of the country. So I would say it's croplands. And forest could be, but they are actually quite protected in Costa Rica, so it's not the case.
Okay, thank you. This is an answer I was looking for because it's a huge debate now in my own country. So I wanted to see what is the policy in other places of the world. Thank you.
Thanks.
We have another question by Prasadi Senator. She asks about the assignation of the weights for the factors. So how did you assign the weights for the factors and reclassify them? Was there any procedure or are there random allocations?
I considered previous research in order to assign the weights and the factors actually. For the factors, well, for the suitability scores, for example, the wind energy classification came from the National Renewable Energy Laboratory. But regarding the weights, I followed another research papers that did this. But there are many options actually. You could use pairwise comparison as in the last presented paper. But I think that the weights there are a bit too specific. Like the way it's too mathematical, I think it's not very, I don't think it's appropriate for this case.
Okay, thank you very much. I think that answers Prasadi's question. We have time for one very last quick question from our audience, from Anish Chatri. Wind energy suitability could be done in sea and oceans within the geographical area of the country. How could this be done in the case of seas and oceans?
Does he or she mean like offshore wind energy?
I think yes. I think that's what she or he means.
Yeah, there are not many. I don't know what should be considered, but I guess there would be lots of availability. It should be near the coast, for sure. So the distance to the coast for installation procedures. And the wind speed, I know it's been considered. They are trying to get wind data, wind speed data for the oceans. I saw some projects that are doing this, but I don't know which other factors.
I think there might be also protected areas in oceans. I'm not an expert in this topic, but I think this might apply as well.
Yes, probably also. Yeah.
So thank you very much, Alba. Muchas gracias.
Thank you.
And yeah, so now back to Ian.
Thank you.
Hello, good people, and thank you, Alba. Awesome talk. Yeah, regarding that last question, I believe the criteria that are needed to consider offshore wind needs to be revamped entirely. There's a few that overlap, like you said, wind speed and etc. But yeah, like hurricane incidents, things like this could also play a factor. But yes, unfortunately, we have to move on to our break, first coffee break. It'll be 15 minutes long. I'm gonna play this amazing graphic of a sand timer, and you guys have 15 minutes to kind of have a break. It's starting now. And yeah, we will be back in 15 minutes. Please take a break, get up, stretch, take a coffee break, something like this. And we'll be right back. Thank you. All right. Welcome back, everyone. These are the last 5 seconds before our coffee break ends. I am sorry about that terrible noise. I did not know that played from this thing. And yeah, oopsie. Welcome back from the short break. We will continue with the presentations of 2 more short papers.
Welcome back on my behalf as well. Julio Cesar Pedrasoli will present on behalf of him and Joyce Gennaro Gomez their paper, Development of an Interactive Time Series Sampling Tool for Urban Environment, Land Cover, and Land Use Indicator Concept Test in Salvador, Bahia, Brazil. May I also note here that Julio is also organizing a workshop for us tomorrow about accessing, mapping, and exporting nitrogen dioxide data on Google Earth Engine. And as always, we have reserved 5 minutes in the end for your questions. Please, Julio, you can go ahead.
Well, thank you. First of all, I want to say congratulations for the organization of the event, and say thank you for the opportunity that you give me to share some time with you. Well, this short paper I'm co-authoring with Joyce Gennaro, who is a PhD candidate in architecture and urbanism at São Paulo State University of São Paulo, USP. Maybe some of you know. Well, my name is Julio. I'm from Federal University of Bahia in the city of Salvador. And it's actually the same city that Dr. Paula Moraga showed us in her presentation about the leptospirosis analysis and so on. And as you could see, it's a very complex urban area, the city of Salvador, and it brings us to the discussion about what I want to try to do here. When you look to Salvador or other similar cities on the global south, they are very complex, a huge gap in income, huge inequalities in these areas. In Brazil, for example, since the late 70s, the Brazilian cities are huge. Brazil itself is not more a rural country. It's much more a urbanized country since late 70s. And it's changing very fast. A lot of slums, a lot of new things in the cities. The cities are huge here and in general in the global south, but in Brazil, it's quite huge compared to other countries in the global south. And all these changes in the urban fabric and the urban structure and the physical characteristics of the urban areas, it's what I'm trying to track here using some indicators of gathered from remote sensing scenes, remote sensing images. So what we are trying to do in this paper is to show how we can estimate some indicators, always thinking the city as a system of systems. So when you think about it, it's exchange of matter and energy. So some energy comes in, some amount of energy comes out, and there is a balance between them. And the materials and the surface will respond for that exchange over time. So as the city changes itself, the way the energy and matter exchange over the time will change. And in order to track it, there's a lot of tools to do it, a lot of things being done to analyze this kind of things. But I'm working in different projects, applying this kind of analysis to different objectives. And I'm in the course of developing a tool for estimate the proportion of occupied area by vegetation, by constructed area, built area, and how in the same period, how the temperature changes. So this paper aims to demonstrate this, how to extract the proportion of occupied area occupation by vegetation, by substrate, that it's built up area, and surface temperature. And as a concept test, I'm using the city of Salvador, of course, where my university is located, as an example. So this is our main objectives here. The methodology is probably the most important thing in the work. And the methodology basically is related to collection of data from Landsat images in a huge time series, 1984 to 2019. And we apply some temporal filters to choose the best scene for the time series. We have to stack the multi-sensor, different sensors into this cube that we are building, because there is Landsat 4, 5, 6, some scenes of Landsat 7 and Landsat 8 nowadays. And probably the most important thing in all the methodology is the spectral end members, the global spectral end members, because we are applying a technique called spectral unmixing that will look to pure pixel of vegetation, pure pixel of constructed area, pure pixel of water, high albedo, low albedo vegetation, and looking at it, applying a function to calculate how each of these things contributed linearly to the number registered in the pixel. But it always, all the time that you do it, you have to look at that place and took pixels in that place. And what we are doing here to make it scalable, it's to apply global spectral end members developed by Professor Christopher Small from Columbia University, and put it in a cloud service. This is the cool thing about it. So we do all this stuff, calculate the spectral end members, extract the substract and vegetation and the temperature, and put it together in a tool to be able to export the results. And I can apply it in different places of the world, most of the places actually. So just to know, if you don't know, the spectral end members means this, what I was trying to explain right now. It's a combination of different things, okay, in the same pixel, and they contribute linearly. Then you can consider is a sum of all different wavelengths, how they contribute to form that final wavelength. Okay. So let's discuss what is important now. The results and discussion. I'm looking here at the city of Salvador de Bahia. All these gray areas are urbanized areas. The red ones are with greater vegetation areas. And what I did was just to use the tool that I'm going to show you right now. I don't know if you can see my screen here. Okay. So I just put this to show this online to show you. So this is Salvador. I can choose one of the types.
To interrupt. We can't see your screen actually. It's set to the presentation mode, so you have to share a different window maybe.
Oh, sorry. I will do it now. I don't know if I'm able to do it. New share. Can you see now?
No. Now, yes.
Yes?
Yes.
Okay. Are you seeing the Salvador map? Okay, I will just show you how it works. You have a rectangle, polygon, or point tool. You can choose one of them and just draw your area of interest, and you begin to generate this time series for the area. So when you do it, you can look at this. This is an example of substrate and vegetation, how it varies from 85 to 2019, and can actually export it. You can open a different window and export it as a tabular data. Now I will try to back to my presentation now. Sorry, it's a lot of different windows here. I think you are seeing my presentation again, and we are here. So what I did was to use that tool to extract some example in a tricky area. Actually, this is the Dunas Park. It's an area covered by sand dunes, and I extract the three indicators that I'm saying to you that I'm able to extract from anywhere on the planet, and apply some training analysis. And this is a tricky area because over the time, a lot of sand dunes was converted to urban areas. And we expected that this is not an increase in temperature, but this is what actually happened, because there's different latent heat between the sand dunes and the urban areas. So subtracting the sand dunes resulted in a kind of huge increment in temperature over the time. This is just an example how you can extract the data, how you can analyze and use it. Okay, and just to finish, I think I'm the finish. Well, about the tool itself, it's working. We are developing better user interface, putting more things to work together. But looking at the data, it's seem to be quite consistent when we pre-process it and extract the information and use it for this example and others that we have working on. And there is an evidence of that the change in urban surface occupation by construction is some evidence that it's impacting on local climate, especially in the increase of temperature. And I think that's it for now. Thank you very much.
Well, thank you, Julio. That was a very interesting presentation. And I wonder if we have any questions. We have still a couple of minutes left.
Yes, we have a couple of minutes. So if you have any questions, use the Q&A, raise hand, and we will let you speak. So far, I see that we have none, so I'll take the chance and ask one. I'm really excited about all the volume of Landsat data you're analyzing. And I was wondering, because we have used in our geotech course different sources of Landsat. For example, we know for Landsat 7, you have the defect, these black stripes at the sides. And for example, Landsat 5 has different bands resolution. So I was wondering, how do you merge all of these data that comes from different remote sensing satellites? How do you harmonize it?
Yeah, this is one of the advantages of using a platform like Google Earth Engine. I'm thinking all of you are interested in how it works, and probably some of you are already using. You have all the collections. I'm using the tier 1, that is the best one, that can get the information that it's more adjusted, geometrically adjusted, and with greater spectral adjustment also. And to put it all together, it's quite simple. You just need to specify the bands in the Google Earth Engine, to select them and say to the computer, say to the code, which band it will be renamed to match with the band of the subsequent satellites. Like Landsat 5, there's no the same bands names in the Landsat 5 or 8, and there's more bands in Landsat 8. And this is a problem for the end member extraction, for example, because the band names and the range, you have to equalize them in order to apply the end member extraction from the linear unmixing. I don't know if I answer your question, but it's quite easy now.
Yes, it is. So basically, this Google Earth Engine and all these platforms have already the catalog that it doesn't require so much transformation.
Exactly. Oh, it's almost all ready for use now.
That's very cool, and I think that many people attending the conference are looking forward to your workshop, me amongst them. So thank you again, and I think we're ready to go to the next presentation. Big round of applause for Julia. Thank you.
Thank you.
Thank you once again. Can you see my screen? Great. So moving on to the last short paper presentation for today, Jordan Bates will talk to us about winter with LAA estimation using UAV mounted LiDAR. Jordan is a recent graduate of Geotech and is already working as a researcher. It is very nice to be hosting him this year, as we can still remember last year's remarkable organization. Give him a huge round of applause and save your questions for the dedicated time slot in the end.
Thank you for that great introduction, and I'm happy to be here, and thank you for the opportunity. I'm going to quickly try to share my presentation, so just give me a moment. Okay. And can you see my presentation? All right, perfect. Yes. Okay, yeah, just like was mentioned, I am a doctoral researcher at Forschungszentrum Jülich. Also, a PhD student at University of Bonn, where my research is funded by the FINEROP Cluster of Excellence Research Group. I am from the United States, where I am currently now in for the holidays. So it's a little bit early here. Also, I just got filled up on Thanksgiving turkey, so I apologize if I'm a little bit slow. Yeah, so at the Research Center, we have several projects going on with unmanned aircraft vehicles, ranging from hyperspectral sensors, multispectral sensors, LiDAR, thermal sensors. But I'm just going to talk more specifically about one project we just kind of started in its earlier stages, but is very interesting, and that is calculating leaf area index for winter wheat using LiDAR. And I've listed the co-authors or also my supervisors for this project, and that includes Professor Dr. Francois Genard, also Dr. Karsten Monska, and Marius Smit. And so quickly going into it, just give you a brief overview. Most of you already know this because it's a hot topic, but drones, they provide much higher temporal resolution. You can fly them. It's a lot easier to find access to drones. You can fly them underneath the clouds, and really it's much better than being on the time schedule of satellites or also trying to put a team together to do airborne missions. Also, they provide much better spatial resolution. You can fly much lower. And also in a lot of cases now today, there's many hyperspectral sensors coming out where you can increase the spectral resolution of the data you're getting with drones. And so with that, a lot of times at the Research Center, we're using that to incorporate with crop models with these advantages to basically in the end provide more precise application of fertilizer and just overall better precision farming management. And so what I want to talk about today is about leaf area index calculations or metrics. And many times these metrics are calculated with passive optical methods or with very different bands of vegetation indices. And a lot of times this is more reflective of leaf pigment, or they rely on leaf pigment and the difference between the reflection of the crop in comparison to the reflection of the ground. And sometimes this is more reflective of green area index, or really the photosynthesis, the areas of the crops that are really still photosynthesizing. And so what we want to look at is there other alternative methods aside from these passive optical methods that really are just react to the leaf pigment, but also can calculate more of the above ground biomass, such as maybe with LiDAR. And you can see how that's a problem a lot of times with cereal crops like winter wheat, when earlier in the stages we get a good calculation of leaf area index, as you can see here, like June 18th, but later on when it's reaching senescent stage, and sometimes it reaches senescent stage heterogeneously, not evenly throughout the study area, we have problems with calculating LAI of the above biomass. And so with this project, we did a study area in Zellhausen, Germany. It's a 10-hectare winter wheat field. We did 8 different LiDAR flight campaigns from April 1st to June 21st, 2020. Really the whole aim of this project is to see how we can use LiDAR or the benefits of LiDAR to calculate leaf area index. Most of you are probably already familiar with LiDAR. Basically, it's just a geolocated point based on timing of when the signal was emitted from the sensor to when it was reached back to the sensor. And that geolocation is estimated with the GPS on the drone, and also from the orientation of that signal was sent down and received by the inertial measuring units on the sensor itself. And so really simply in this project, we're going to compare what results we get with the LiDAR system to the already proven passive optical methods.
And then also we did take some ground measurements to also see if we can provide some further validation for this LiDAR method. And then also we did this throughout the entire growing season, so we can kind of also assess how well this newer methodology with LiDAR performs throughout the growing season. And I put a graphic here just to kind of give you an idea of some of the other advantages you get with LiDAR, and that compared to passive optical methods. So with photogrammetry, that's using passive optical sensors. You're most of the time just getting this top information of the canopy. With LiDAR, you can kind of penetrate through the canopy and get more information about the structure and also the underlying ground underneath that canopy. And so in this project, we used a DJI Matrix 600 drone, and attached to that were 2 different sensors that we used in this project. One of those was a MicroSense Red Edge multispectral camera with 5 different bands, and then also a yellow scan surveyor LiDAR system. And so first, I want to just go through the passive optical method we used with the multispectral camera. You can see here on the left side is the time series analysis from April 1st to July 9th. And we use 2 different bands, the near-infrared and red bands, to calculate NDVI. Most of you are already familiar with that. And we use the difference between the values for the vegetation, noted here with a V, and also the reflections values of the soil seen here, to get the difference between those 2 reflectants to get an idea of the fractional vegetation cover to calculate the leaf area index. And you can see as we go through the time series here, you can already see structures appearing throughout the study area around mid-June, late July, as it's getting closer and closer to its senescent staging and browning. And here we'll talk about the LiDAR methodology that is used in this project. So really the whole idea originated with what is done often in forestry with hemispherical cameras underneath the trees. And they basically take a ratio between what is been segmented with the leaves of the trees and ratio compared to the sky that can be seen with the cameras. And they call that gap fraction. And so what we're basically doing is turning that upside down and seeing what information we can get about the ground in comparison to those points on the canopy. And so we're using that advantage of the LiDAR's ability to penetrate through the canopy and see how well it penetrates through the density of the canopy. So we can kind of get an idea of how dense it is to estimate what the leaf area index will be based on that ratio between the points on the ground and then also the total points from the LiDAR scans. And so here we have the results, time series analysis of the basically the passive optical methods, or we have it noted here, the multispectral methods throughout the beginning of April to the end of July, and also compared to the LiDAR methodology, and then also just the normalized RGB imagery. And so we wanted to hold that up next to each other so you can kind of get an idea of how well the LiDAR methods we're using here performs at identifying these structures throughout the study area, just like the proven passive optical methods are doing as well. And you can see that it does a pretty good job of identifying these structures in the canopy. And also it's worth noting that with the optical methods, which are more reliant on the pigment of the leaf, and as it gets later, closer to the senescent stages, as you can see with the RGB imagery, the reflection of the canopy is more like the soil. And so we have a hard time of distinguishing between the structures in the canopy to those the ground. And so you can see with the LiDAR methodology, we can still identify those structures in the canopy later in the growing season, and senescence of the crop is not a factor. And so to also give some validation to this methodology, we did spatial sampling throughout the study area to see what correlation there is throughout the growing season. And you can see there's a high correlation between high to moderate correlation between the LiDAR methods and the passive optical methods at mid growing season. But later on, there is no correlation, of course, because there are 2 different methods. One, like I've mentioned several times, is more based on reflection, as the other one is based on the density of the canopy, and where we can still identify better about the above ground biomass of the plant. And so going into the ground sampling that we used also to try to validate this methodology, we have one area here noted in A, where we used a septometer, which uses also elements of gap fraction below the canopy to get an idea of LAI. And then we also have a destructive measuring plot here where we scan the leaves, which is a more precise way of gathering LAI. You can see that the LiDAR methodology actually performed very well compared to the septometer measurements, which is the SS1 Sunskin septometer, up to around the beginning of June. But later on, it looks like it may be overestimating a bit. And we verified that later in the growing season with their destructive measurements showing that indeed that the LiDAR method may be overestimating slightly as compared to the ground measurements. And so just to wrap up, really this whole project kind of shows evidence that LiDAR may be able to be used to estimate LAI. However, we did get some overestimation later in the growing season, as much as 28%, but it performed pretty well early to mid-growing season, 3 to 12% error. And really what we're going to focus on in the next year, for at least this topic, is to try to increase those accuracies. So there are some studies with forestry using LiDAR for such metrics as well. And some of the ways we can improve these accuracies is getting a better idea of the crop canopy by improving maybe the scan overlap, the directions we fly the drone to get different perspectives of the canopy gaps, also the height we fly at, and so forth. And also there's other ways we can improve the accuracy aside from the flight collection methods, but also maybe the processing variables or methods, such as we have different attributes of the LiDAR signal we can also use, such as the signal intensity, also the echo numbers, and also we could also process the returns at different heights within the canopy to maybe improve that accuracy. And so really in the future concept of using this, these results, we want to incorporate this with certain crop models to improve, like I said earlier, the crop management overall. But that's it for now. And just thank you for the time, and I can take some questions.
Well, thank you very much, Jordan.
Yep.
Virtual applause. And are there any questions for Jordan, Carles?
Yes, there are two questions from the audience. The first one is from Julia Melisse, who is a colleague of ours. If I'm not mistaken, she's also working on LAI estimation, so she's working on this topic. Julia said, I really like this study. I was wondering if you are going to compare the performance of LAI with other VI's biophysical parameters. That's Julia's question.
Right now, there's no plan for that. So what I showed, that's all the comparison we're doing right now. So we're also focusing on some other topics. So that's all we had available for this season. And I think we're just going to be using the same comparisons in the next season as well.
Okay, thanks. There's another question from Sedun. Thank you for such an informative presentation. We need to have high positional accuracy, especially on UAV and LiDAR, as usually GNSS in drone are not very much precise in drone systems. How did you manage to obtain good precision?
So it's precision with the georeferencing?
Yes.
Was the question? Okay, yeah, that's so what we use with the LiDAR, if that's the question, not the passive optical methods, but we used just direct georeferencing with the base station. Actually, currently, when we were measuring those, we actually didn't plan to use LiDAR in this way, and we actually didn't focus so much on precision georeferencing. So later on, we actually did some post-processing to increase the accuracy. There's actually available a method with virtual reference systems, which uses dedicated reference stations and triangulates a position for us to estimate a more precise location of our scans. And really what those stations are doing is just logging the positions of these satellites and comparing it also to the location and GPS of our drone to get a better direct georeferencing accuracy.
Yeah, that's very cool. Thank you. We've done a bit of drones in the geotech program, so it's good to know other techniques. We have a question. I think we only have time for one more from Christoph Brox, who says that it's very good to see you. You develop and you apply your methods for winter wheat in Germany.
Yeah.
This is fine, but for which other applications could your methods and techniques be used and would be beneficial? For example, in global problems like crop management in sub-Sahara.
Yeah, well, I mean, we're hoping that this could be applied to almost any crop, but that's the problem I had when researching this. There's very little articles, very little research being done on LiDAR with drones and estimating LAI. It's already been only in the last maybe half decade that LiDAR sensors have been small enough to mount on UAVs, and let alone being used to estimate LAI with crops. So there's a lot to be done, but this is a start with winter wheat. At least one crop down, we're getting an idea of how to create very accurate estimations of LAI, maybe even better than what we can get with the passive optical methods. And so, yeah, there's plenty of room for more research in this area, and hopefully, yeah, this could be applied on a greater scale and many more crops.
Thank you. So we will be looking forward to your progress in this field, in this exciting field. Thank you very much again,
Great.
Jordan. It's a pleasure to have you here.
Yeah,
and
thank you.
Big good round of applause for Jordan. Thank you so much. I think we can move on after here.
Yeah, great.
Okay,
thank you for having me.
Thank you. I can still see an unanswered question, but we're running a bit late to answer this like live. But Jordan, if you want, you can take some time to type your answer while we proceed with the next presentation, if that is okay with you.
Yeah, that's fine.
Thank you. So this concludes the short paper presentations for today. And please join us tomorrow for digging into more interesting topics. And to move on, this year we are more than honored to host Contera, a leading geo-IT solutions company based in Münster, Germany. Contera is a member of the Open Geospatial Consortium and Esri Partner Network, among their other affiliations. Today, Alexander Strothmann will present on behalf of the company, and give him a round of applause again. Let us know in the end if you have any questions. Oh, are we going to have any questions in the end? Okay. If you have any questions, yeah, please write them down.
Okay. Thank you. I will start the presentation. So are you able to see anything?
Yes.
Ah, perfect. So yeah, thanks for the opportunity to have a few words on Contera.
You can see your desktop, not a presentation.
Yeah. Oh. Now it should be
great. Yes.
better. Sorry. Yeah.
Thank you.
Yeah, so Contera is a sponsor on the Geomundus 2020. So thanks for the opportunity. And as we did it in the last years, in the career session of the Geomundus studies, we want to take the chance to present the company and tell you a few words what we're doing and what it's all about. So I'm working for Contera for a bit more than 10 years now. And yeah, as I was introduced, I'm working as a project manager for yeah, software projects regarding GIS and integration of GIS. And my customers are mostly all in the field of telecommunications. So what we do is we try to build up GIS-based solutions which are used every day. So at your work or where authorities deal with, but also where everybody deals with in his spare time. And so our history is yeah, mostly 30 years ago started. So we were founded in '93 out of the Institute for Geoinformatics at the University of Münster. which you probably all aware of. And we pretty much shortly directly got partner of Esri, so in '95, and also of Safe Software, which builds the software FME, if you are aware of it, in the end of the '90s. So in the early 2000s, we, again, with the Institute for Geoinformatics, founded 5 to North, which is a non-profit organization for dealing with in the field of GIS and research projects in GIS. And then we got together with Esri Germany in 2006. Yeah, so we reached the 100 employees mark in 2011. And meanwhile, we are more than 170 employees. So we, as we were introduced, our headquarters is of course in Münster, but we also have branches in Germany, in Cologne and Berlin. And meanwhile, also a couple of bureaus in Spain, because we have a couple of customers in Spain for the FME software. So we have bureaus in Barcelona, Madrid, and Vigo. But generally, we're focusing on the European market, but we are also globally active with partners all around the globe. We have sales partners in the US, which are selling our products, and also in Australia. And as I mentioned, we are a partner of Esri Inc. and Safe Software. Our services, or our everyday life, is that we consult GIS regarding GIS integrations in the enterprise field of companies and also public authorities. We implement solutions by ourselves. We implement our own products with what enhance the capabilities of the so-called base technologies from Esri and Safe. We customize software, and we provide managed services. So our idea is that in the enterprise field, we have a huge field of business processes the authorities and companies are dealing with, but a large of this part is dealing with GIS, and we try to integrate our software on top of the ArcGIS platform from Esri, and enhance this, as I said, with our own technologies. We have 3 or 4 own products which enhance the platform regarding map client, and also fine-grained security for accessing data and granting permissions. And of course, we have the FMA technology, which deals with data integration and data transformation. So how to get data from one into the other system, and how to get real-time data into the system, and all this stuff is our topics of the FME part. This is another slide regarding our organization. So as I already told, I'm working in the field of telecommunications, but we also dealing with other markets like insurances, and the public parts are like SDE and e-government in public authorities, and also we are helping nature and environment authorities to organize their GIS workflows, and we're dealing with companies in the real estate field. So a few slides which are give you examples of our customers. So one of our biggest customers is Vodafone Germany in the field of telecommunications, We, for example, built systems for helping customer care agents, which have to deal with the current status of the network and have always the real-time view on current outages and all this stuff. We're helping Bavaria in the organization of winter management service systems for the motorways. We're helping insurance companies like Itago. We help the European Commission with providing the European data portal. We help real estate companies and authorities, for example, with the landscape and playground cadastre. And we also are busy in the forestry authorities, like the state enterprise Sachsen-Forst in the state of Saxonia. And last but not least, we try to give current information for ground prices for the public, like when you want to build your own house, and that you have a current view on how much you have to spend for the square meter when you want to buy your own land. Of course, we are also always searching for good people, and people are enthusiastic in the GIS field. So these are maybe 4 profiles we always searching for. So it's important for us to have good software engineers. Here's a quick view on skills and things software engineers do in their everyday life at Conterra. We're also looking for consultants and software architects because we always deal with complex systems in the enterprise field when we have to integrate our software into existing systems at the customer side. Of course, we also have people who are dealing with sales processes in their everyday life, because we are a reseller of the FME software in Europe. And we are always open for internships and placements. So this is always possible. Here, a quick view on current positions we are searching for. And maybe you find interesting chance or opportunity for yourself, then of course get in touch with us. Or what you also can do is you can configure your own dream job. But I don't want to spend many words on that, because my colleague Ala Abdel is joining the career session this afternoon, and I think he will tell you a couple more things about this, because he was the main developer of this tool. Yeah. Last words on our corporate culture. We always try to do many things together, and when there is no corona or no other virus, we also do things in our spare time. So it's a very, very busy culture beside the work. Just a couple of resources where you can get in touch with us or follow us or get news from us. So feel free to join us, to subscribe. And that's it. So if there are any questions, I think we have still a minute left. Otherwise, as I said, Ala is taking part in the career session this afternoon, and I think he enjoys it when you have questions or are interested in getting in touch with Conterra.
Great, thank you. Virtual applause.
Thank you.
Are there any Q&As?
Hi. I think that for the moment there are none, but as our panelists said, Conterra will be also the career development session, and they have presented a really nice overview of the company and possible opportunities for us. So please feel free to participate later, and we look forward to welcoming you all to that career development session. Thank you.
Great. And we can always reach them in their social media provided as well.
Of course.
Well, see you in the field of GeoIT solutions. And at this point, we are going to have a break for lunch. You will have plenty of time to cook, eat, and digest. Since we cannot welcome you to our buffet and share the same food, we will share a recipe instead as a proposed meal for the day. Keep in mind that there are more interesting activities in the afternoon, another keynote presentation, an alumni session, career development panel session, and of course, the virtual networking session, the links for which you should have already received by mail. Please enjoy the break and see you in about 1 hour and 15 minutes.
Good afternoon, everyone. Welcome back. Hope you enjoyed your lunch break. It is my pleasure to introduce to you our 3 alumni as we proceed into the alumni session. First, we have Daria Lutka of Switzerland with WIGA. Next, we have Ignacio Panzoda Llorens of Spain with Cognizant. And last but not least, we have Mahesh Thapa of Nepal with the Department of Surveying. Hope you all enjoyed the conference so far, and we're excited to hear your stories. First, we'll have you guys introduce yourself, and then we'll have some time for Q&A from the audience. I'm going to stop sharing my screen, and if you are able to begin sharing, we'll begin with Daria Lutka.
Hi, can you see me?
No.
I think you can only have 5 screens at the same time, 5 videos, so I think I'm blocked.
Can you try it now?
Nope.
It's not working.
My webcam is on, that I can tell you, but it does not translate to Zoom.
Okay, Carlos, nothing? Okay, is it fine to give us an introduction without a presentation?
Sure, no problem.
Okay, thank you, Daria.
All right, so I graduated the Geotech Masters in 2018. I was in the Lisbon track, actually, like Mahesh, so nice to see you again. Thanks for inviting me in the first place. It's also nice to have startup represented because it's something that I had not been exposed to too much during my studies. And yeah, I mean, I can give you a brief overview over my path so far. So I graduated, I kind of started immediately after as an intern at the UN Spider in Bonn. So doing disaster risk management, GIS, remote sensing work. It was pretty nice because as a first professional experience, you know, just dealing with international stakeholders. And I would definitely say that the geotech background helped me there just because of all the exposure to different cultures, different people. And it was also very nice to have like NGO experience and just to see how the specific sector works. After that, I actually went back to Lisbon. I worked at DGT, which is like the Land and Cadastre Center Ministry in Lisbon on a research fellowship. And it was facilitated by my master thesis supervisor in Portugal, Mário Caetano, who also teaches the remote sensing module in Lisbon. And well, very similar work, a lot of R-based coding, again, GIS and remote sensing, and same international environment. And was half a year, and it was also much appreciated because it gave me insight in governmental workings and how state-supported agencies are progressing, are doing their work. And well, immediately after that, March 2019, I joined WIGA, which is the company that you just mentioned. So it's a Swiss startup who uses EO to monitor water and snow resources and properties for hydropower. We're a tiny team of 5 people, and again, international. I was initially hired as a remote sensing lead to build a snow detection system from scratch for a project by the European Space Agency, which was very exciting. We worked on the whole project and like the whole project cycle from ideas, implementation, customer exposure. So yeah, it was really cool. So really doing system and user requirements, learning about product management, system and service architecture, so Python and Docker, all the tech stuff, data sources, how to combine them, how to verify systems, and of course, all the kind of general stuff like project management, business development, dealing with users, stakeholders, and also grant applications. And since June now, I am CTO, Chief Technology Officer of that same startup. responsibilities are kind of similar, a bit less techy, definitely more involvement on the business and management side, and a lot more exposure to innovation, partnerships, well, a long-term vision for the company. And right now we're just finishing another project for ESA, and we're moving the company more towards sustainability and other renewable energies. So it's pretty exciting right now. I know, would you like me to continue with like some advice, or is it later?
So that's later. We're going to go into our meet with our next alumna. Ignacio, are you there?
Yeah, I don't know if you can see me. Yeah.
So do you have a presentation you would like to share with us, or would you like to?
No, I didn't prepare.
Okay, so just introduce yourself.
Okay, so hello everyone. My name is Ignacio, and I did this master. I just finished this year. On March of this year, I present my final project. And well, just to give you a little bit of background about myself and about why I joined this master, I study geography in Alicante, which is quite close to Castellón. And then I joined this master because I just saw that it was quite interesting, and because of the part of mathematics and IT that I didn't knew like anything about that from my bachelor. So yeah, that's why I joined there, and I have to say that I learned a lot, like especially in Castellón. The first semester it was hard for me because that's the truth, but I learned a lot about how to program, about databases, about mathematics. So yeah, that was great for me. Also, all the other classmates who came from different backgrounds, and also of course for me, I learned a lot of English, which was really helpful after I finished the master. And yeah, so about my career, about my experience, what I did, I didn't receive the Geomundus scholarship, so I had like a little more of freedom there. So I did the first semester in Castellón, then I went to Germany, and then I joined this company called IDOM to do my final thesis, which was about analyzing the Madrid the Madrid bus fleet workflow. So after that, I finished the thesis, and I joined this team. So I joined in land management department, and I was working there here in Madrid until a couple of months ago when I joined Cognizant. So I'm working like full remotely now, which was something that I really appreciate. And I also like all my team. It's composed for people from other sides. So that's one point for me from this master, because I learned a lot of English, and I can join now these kind of positions, and also the part from technical, because what I'm doing now is working with transportation, like public transportation data, and checking the quality of this data. And obviously I'm doing that just like by programming and by analytics. So yeah, probably I can say that these two jobs that I had until now came just because of the master. So yeah, I think that's all.
Okay, lovely, Ignacio. Thank you so much. Next, we have Mahesh, and he is going to introduce himself as well, and then we'll open the floor up to questions. Mahesh, are you there?
Yeah, can you hear me?
Yes, just fine, thank you.
Okay, so I've prepared a presentation. Just let me share it. Yeah, can you see my slides?
Yes, perfect.
Okay. First of all, I'd like to thank the organizers for this opportunity to reconnect with my university, to the professors, the coordinators, and to the friends of the program. My career has been relatively simple. I mean, I did my geomatics engineering, bachelor in geomatics engineering. I've completed it in 2011. Then since 2012, I was working for Survey Department of Nepal, which is the National Mapping Agency of Nepal. Then from 2016 to 2018, I joined the Masters in Geospatial Technologies. I was fortunate enough to get the scholarship to join the course. Then once I completed it, I came back and rejoined the Survey Department of Nepal. This organization is it's a government organization that does a lot of geospatial activities, and it's quite an enlarged organization. It has like more than 130 organizations, other offices in different districts of Nepal, more than 3,000 employees. So basically, it does a lot of activities related to geospatial sector, and that ranges from like cadastral mapping of the whole country. It implements spatial data infrastructure, and also it creates and updates all these topographic maps. So it has quite a lot number of activities that it does. Once I came back after the completion of the program, I worked into very exciting sectors, and one of them was to develop the National Spatial Reference Frame. I mean, for a lot of geospatial users, we already take it for granted, like how do all these layers of information we map using different technologies, and at different time, how do they align one over another. But for several countries, it's already, the reference frame is already there, and then they do not have to think about it. But in Nepal, it's not that condition. So I worked for this work to develop a reference frame. And another thing that I got the opportunity to work is to remeasure the height of Mount Everest, which was never being done by Nepal, although all the Mount Everest is in Nepal. So let me just talk a little bit about these two shortly. The Nepalese reference frame that we use to map all this geospatial data is basically a traditional one based upon monuments whose coordinates are known, like the pillars you see on the screen. What we are trying to develop is a reference frame that is based upon global positioning system, because global positioning system is something that we all now use to map. So we need to if we want to do the next mapping, we want to align it with all data as well. So this is something we are doing. The next project that I'm doing is the remeasuring of the Mount Everest, which we call Sagarmatha. And we are just weeks away from announcing the height of Everest. And these are some of the photos that you can see. It's a lot of surveying and mapping activities, and then doing that in very rough and very difficult terrain. But also it's about processing all this data, collecting all this data, and then processing it, and finally defining the mean sea level of everywhere on Nepal, and then determining the height of Nepal. So to talk about, I think, the implication that this program has had is, I think I've learned a lot of new geospatial tools and technologies. But I think it's not just about the specific tools and specific subjects. But I think what is nice about this program is you get the opportunity to have this international exposure. I made a lot of friends from different countries, share the culture with them, and also learn to work in teams and also work independently. And I think this is the great part of this. This is something that I did not explicitly realize before I was asked to do the presentation, is we have quite a large number of students who are Erasmus Mundus alumni and who are working for this organization, and they are really doing some excellent jobs here. And each of them is taking lead in different sectors, like some working in special data infrastructures, and then some working to develop the cadastral application systems. So I'd like to again thank you for the program, for having this giving this opportunity to join this program. And I'd like to end with this photo of Geomundus 2016, where at least we could be in person, and hope we'll have a similar kind of in-person conferences soon. Thank you.
Wow, thank you, Mahesh, for your lovely presentation. So now we're going to open up the floor to the audience to ask you guys some questions. Our host, Christian, is going to join us.
Okay, hi everybody. So
welcome.
Thank you so much, all of you, for sharing this experience that you had. So we have one question. So the question is for Ignacio particularly. So Julia Molise asked about that she is also doing her thesis while working in a company, as you did. So in this case, it would be interesting for everybody if you could share with us how you got in contact with them in the first place, to the company, please.
Sure. So first, I forgot to thank you for your effort to do this Geomundus in these conditions. So I just forgot about that. And about the question, first, I want to say that you have to make a balance between this TFM or this thesis with the company and knowing that you're going to lose some academics parts when you do that. So I just want to keep that in mind for everyone. And for me, I checked that, well, I had quite sure that I wanted to do these internships before I finished the master. So I checked which companies already had some contacts with the master. And what I did was to check previous years, and I found this IDOM, which like 1 year before, I think, had one meeting with all the students from Castellón. So I contact Carlos, who is a teacher in Castellón, and he was the one that was in charge with that kind of stuff. And I just asked him to bring them back like a couple of times. I asked for that. So finally, they came again to the university. They make their presentation, and I was able to talk with them and to ask them about this possibility. So yeah, that was the way I did it.
Okay, thank you so much. So we have another question from the people to Ganesh. From Ganesh, sorry, to all panel members, please. What, in your opinion, is the best thing you gain with the course or being part of the Erasmus Mundus student, please? So you can answer maybe a little presentation or answer, please.
Okay, so I can start if you want. I feel that it really depends on your background. For me, for example, I really feel a big lag on statistics. And I know that the people from Lisbon had been like having subjects related with machine learning and maybe more statistics than what I get. So yeah, for me it was statistics, but again, I really feel that it depends on your background.
I can continue.
Yeah, please.
The best part, I would say that if you're happy in the geo sector and you do this master's, you have kind of a proven adaptability and international credibility, which is becoming more and more important nowadays. So if you do this course, you know, or employers will know that you can deal with international team members. You have some type of cultural sensitivity, and that you can adjust to different team dynamics and situations in the company. So that's pretty good.
Okay, thank you for your answer. Finally.
I think for me, it was personally, there are a lot of activities in the program where you get the opportunity to independently do several projects, and that teaches you to do things independently. And I think that's something you could implement in your work once you go to some organization, and that just makes things smooth.
Okay, thank you so much. So we have time for another question. This is from David Alcina. So the question is particularly to Daria. So in this case, you have worked in different sectors from NGOs to startups. So do you have any advice for the students that are currently finishing their masters on job opportunities in these different sectors, please?
Well, it's a bit difficult because all these sectors kind of have different requirements. First of all, I can recommend all of you guys just finishing your degree here to try different sectors. For me personally, it has been very beneficial. Either way, I can give you the advice to kind of create a proven track record. So that could be a GitHub repository or blog, something we can have evidence of a technical work. Then it's also always a benefit if you have the ability to maybe connect with some people, talk to them about the department that you're interested in, and just find out more about their work and what this work specifically requires. And yeah, please don't hesitate to reach out to those people, because most of them are quite happy to answer if you ask them nicely, and they can give you the advice steering you in the right direction. But I would really advise to not narrow it down too quickly, because you're still young, you have opportunities, and there's so much in the geo world to discover.
Okay, thank you so much for your suggestions and recommendation. So finally, we have last questions from the YouTube channel to Mahesh Thapa. So basically, you joined your previous job on same position after completing your master's. So what differences did you notice it brought on your performance and expectation from your organization, please?
Well, since I work for the government organization, and then it really does not matter if you have masters or if you are just undergraduate, you basically work for the same post. But the thing is, after you have this master's and then something that you did in some different country, then basically the expectation of the organization is like, you need to lead something. And personally too, we feel that, I mean, you have got this master's degree, which is such a good degree, and you have a lot of skills and knowledge, and then you need to give your best and then try to implement as much as possible in the organization.
Thank you, Mahesh. We're going to have to wrap up the questions for today. If you do have additional questions for our 3 alumni, please feel free to private message them. They'll be available to you. And also there's potential that they may be at the networking session afterwards. So get in touch with them if you'd like to have a conversation. So give us a big round of applause to our alumni. Next we have a presentation with the GIS director of the Ras Al Khaimah municipality. Please welcome Aisha Said Shehi. Thank you for joining us today. Aisha, welcome.
Hi, thank you. Thank you to let me be part of this today. It is actually evening now in UAE. It's almost 5 o'clock now. So I will give you a brief about the GIS Center and Ras Al Khaimah government. Ras Al Khaimah is one of the Emirates in UAE. I need to share my presentation. I don't know. Can you give me?
Yes, so click the share screen button at the bottom.
Okay. Can you see my screen now?
We can see your screen.
Okay, so Ras Al Khaimah is one of the Emirates in the UAE. And the GIS Center is under the municipality currently. GIS Center is established in 2016, yani almost 4 years now. Once we start having a GIS Center in Ras Al Khaimah, we start looking at the strategic objective of having such things in Ras Al Khaimah. Especially, it will help a lot of people in the government side and the private sector. So we put as a strategic objective that we need to be the trusted spatial information. That means GIS Center will be the source of spatial information Ras Al Khaimah government. Then also the spatial information is accurate and published and managed through the SDI of the government. Also, one of the major strategic objectives is discoverability and accessibility of the GIS spatial data. So the information will be easily found and discovered from the different stakeholders. The spatial information is easy to share across the agencies. And also spatial data is made available in a format and via channel according to agency need and based on their use. Activated spatial community. On that, we are looking to spatial information and system are well governed across the government, and spatial information gaps are addressed and coordinated across the government itself to reduce duplication and the effort between the agency plus the cost. Ras Al Khaimah government agency hold an opportunity level of spatial maturity. At the end, we put one of the also major strategic objective that we need to be to have a strategic. Sorry, I missed a strategic location intelligent. That means we are looking to have an AI when there is a need for a location intelligent, and all our customer experience have a benefit of using this spatial component. On that, first we define the role and responsibility across the government. So some of the agency create data, some of the agency use this data, and some of the agency looks after the data. So we can imagine that, for example, a municipality create a parcel data or cadastral data, and other agency will look after the data, and the other will use this data. We have different data themes. So we have land administration, environment, sustainability and urban planning, infrastructure and utilities, safety and disaster management. We have a tourism as a data theme, transport to economy or community. Physically, Ras Al Khaimah is one parcel fabric. So we are looking to the agencies from a different perspective. So for example, here I put some of the example of the agency which is part of our data infrastructure plans. So for example, municipality have the land parcel, land register, building structure, township plans, and the other data set. Department of Economy have a trade license, for example. Public work have a build road, waste management, landscaping. Police and the security agency have, for example, security videos, traffic incident, crime investigation, and etc. So we are looking that all these components of the data should be in one single platform, different data sets. So I give an example here to the Ras Al Khaimah business system. So as a core business, we are using ISRI platform. Then we have an operation system, which is SAP, and we have a document content system, which is ECM. Each these three components link to each other. So we are trying to eliminate the number of systems across the government and the use of GIS across these systems. So no duplicating the effort, and the cost will be reduced. We have another system centralized across the government also, like HR, finance, and etc. We have a specialized systems for example, a laboratory system for the health department. We have a traffic model and etc. And these all components have a data, and all of these components will be linked at the end to the spatial record once we need that to be available for anyone. Here is also, I give an example for the real estate registration and management system. This is one example of what we are looking for in Ras Al Khaimah GIS Center. So we have a master data object as a parcel and the right of way, which is linked to the building, then linked to the relationship between the building and the master object itself. We have the business partner who is looking to the different owners, these are, or other type of business partner. An overview, this is what we are trying to do in Ras Al Khaimah. So we have three main layers. The first layer is the agency's data, and the second layer is the data hubs, where there is a few agencies will be gathered together to have an application or something like that. The third layer is the trusted center for a spatial component and non-spatial component. We are responsible as a GIS center for the spatial component, and non-spatial component is one agency in Ras Al Khaimah government is looking at that, but we are in collaborate with them to have a good architecture for the data in the government. Thank you for that. Again, we are looking for a lot of people in this specialization. In UAE, there is a lot of people who have this background, but still we are looking for, I mean, from the world, who's the best in this field to bring it to Ras Al Khaimah. So be happy to part on that today with you. And thank you very much.
Thank you so much, Aisha. Next, we have a presentation with the Erasmus Mundus Association. As a reminder, if you have any questions for Aisha, she will be available on private message shortly after her presentation, after we change presentations, and also possibly for the networking event. So get in touch with her there. Next, we have the Erasmus Mundus Association with us. Gabrielle Mikiewicz, we'd like to welcome you to the floor.
Hi, thank you very much. If you don't mind, I can share my own screen, if that's okay.
Yes, you may do that now.
Thanks a lot. Here we go, just 1 second. Great. So thank you very much for having me. My name is Gabriela Mikiewicz. It was a good effort to pronounce it, but Polish names are notoriously difficult, so I will forgive it. I am very grateful to have been invited to speak today by Som, who is a volunteer of Emma, and he wanted me to come and say a few words about the Erasmus Mundus Association, so that's why I'm here today. I can start just a quick thing about me. I am the director of the Student and Alumni Relations Unit at Emma, and I am an alumna of the EMIR program, which is the European Master of Migration and Intercultural Relations. So I think our fields are quite different. I'm in the social science field, which I guess is different, quite a bit different than in geotech. But that's one of the great things about Emma, is that we get to network and meet people from all over the world in different backgrounds. So what is Emma? It is an association for the students and alumni of Erasmus Mundus master and doctoral programs. We are linked to the European Commission. We care about higher education and its broad intercultural benefits on our way to get self-sustainable and influence higher education and society. So that's kind of the official term, but what exactly does that mean? So Emma was founded in 2006, partly with help from the European Commission. And we basically are just a group of students and graduates of Erasmus Mundus Masters and PhD programs. Even though there aren't any current PhD Erasmus Mundus programs anymore, we still invite and include people who did an Erasmus Mundus PhD. We actually are over 12,000 members across 170 plus countries. So that makes us one of the world's biggest culturally and interdisciplinary diverse student and alumni organizations. We recently became legal in 2015, and we're based in Brussels as a nonprofit organization. We are volunteer driven completely. There's absolutely no paid positions within Emma, which just makes it even more amazing that there's so many people working to contribute something to this organization just based on wanting to volunteer. We're also part of the Knowledge Alliance of ESSA. So I think that's the Erasmus Student and Alumni Association or something like that. And they have several different organizations under their umbrella. What do? We spread awareness about Erasmus Mundus, about scholarship opportunities, about Erasmus Plus and this quality, about European higher education. So that's, of course, very relevant to prospective students who want to eventually become Erasmus Mundus scholars. We do a lot of community building. We offer personal learning and professional development opportunities. So of course, that's also relevant to current students and alumni of Erasmus Mundus programs. We support our members before, during, and after completion of their studies through Erasmus Mundus. And we really aim to have a global impact. We try to develop a meaningful presence through projects and social impact events. We do all of this through different teams in our management board. So I'll just give you a quick overview of the main people in the Emma management board and which teams they work with so that you can kind of understand what we do. Our president is Katarina Heil and our vice president is Marcella Hussein. We have 4 working units, including mine. So Student and Alumni Relations Unit, Policy and Quality Assurance Unit, Research and Innovation Unit, and Capacity Building and Outreach. Then we have 3 administrative units, Legal and Internal Affairs, Financial Management, and Talent Management. And then we also have a Project Support Unit, Communications and IT, and Partnership Development. So how does Emma reach our goals? Primarily, of course, through our volunteers. We currently have over 100 motivated volunteers, all working towards common goals. We also reach our goals through our projects, especially our projects unit, which I just mentioned on the previous slide. We have a lot of projects that receive funding from the European Union through the ESSA's funding scheme. If you're ever interested in a specific project or have an amazing idea for something, but you don't really know where to start, you can absolutely feel free to reach out to the projects unit in Emma. And we're doing a lot of really cool stuff there. So I will introduce you at the end of this presentation. We also hold our annual General Assembly with all of our volunteers and members. Of course, this year it was virtual, but in other years we've been able to actually invite some of our program representatives, country representatives, and very active volunteers to attend in person. So that's a really amazing opportunity. We also really heavily rely on our PRs and CRs, which are our program representatives. They're the ambassadors of Emma within their programs and the ambassadors of their programs within Emma. And our country representatives help students from around the world prepare for their Erasmus Mundus courses, and they also do a lot of regional and local-based events and networking. So a bit more about the country representatives. They promote Erasmus Mundus around the world. They assist prospective and new students. They create local EMMA communities. They're kind of the ambassador and contact point of EMMA at a more local level. They assist with events such as pre-departure webinars, and you can contact the country representatives if you're interested at all through this email. And something else that I think is really interesting about the CRs is that they're often very in touch with the European Commission presence wherever they're located. So if the European Commission wants to do a special event for Erasmus Mundus students, very often the country representative is the one organizing the event with them. So I think that's a really cool, one of the cool ways that we do have a link with the European Commission. For Geotech, there is a PR already, Som, who invited me here today. So thank you very much. PRs work to improve the quality of your EMJMD experience. So they don't just work for themselves, but they work for all of their students and alumni. They work to improve relations between EMMA and your course, for example, being the liaison between the course mates, the coordinators, and EMMA. Or they can invite people like me to speak at events like this, which also brings EMMA and your course closer together. The PRs promote EMMA to students, and then they also promote the EMJMDs to a wider audience. They also help support job placement and professional development by connecting all of you students and alumni to different events and programs and opportunities that we have at EMMA. They also help to create a network of geotech students and alumni through blogs, events, etc. And of course, what's really cool about being a PR is that they get to really interact with other PRs. So right now we have, I think, over 40 program representatives, and we have like a Facebook group, a WhatsApp group, and of course we're in touch via email. So I think it's a really great way to get to know other people. And this photo here is from the General Assembly in 2019. So if you'd like to get in contact with anything related to program representatives, I would ask you to reach out to Som, of course, eventually program.representatives@em-a.eu. And we do have a special email address, coordinators.prnet, which is the only email address that we communicate with EMJMD coordinators through. So if the coordinators are listening and you're not receiving emails from EMMA, but you would like to and some other information, you can go ahead and reach out to this email address here. So what your PR does, I'm sure some can explain some more eventually, but it basically falls under 4 categories: communication and advising, social events, promotion, and there was a few other things. I'll just go ahead and skip this slide because I don't want to take up too much of your time. I'll also go through this quite quickly. So through EMMA, you have access to a lot of different networking and professional opportunities. We have an online community platform, so you can register there through our website, which I'll have the link to later, but it's basically em-a.eu. We'll soon be starting up a mentoring program in the professional development unit or team, so that's really exciting. We have an EMMA podcast. We have an EMMA Academy Leadership Academy. We have networking evenings, changemaker events, campus Erasmus, different trainings, workshops, etc. So as a member, you would be able to participate in all of these things. And in terms of research and advisory on quality of higher education, we also have some projects in place. We do course quality surveys. We help with graduate impact surveys from the European Commission. We help with degree recognition surveys. We also participate in the ESSA Jobs of the Future survey. So if that's something that you're interested in, course quality and stuff like that, you can also get in touch with our quality assurance team, which you can find more information about on our website. This is something that I'm very excited to introduce to you today. This is a brand new initiative from Emma, from our projects team. So they're really doing some amazing stuff. And so this is called Emma Genie. It is digitally mapping the Emma community. So the little elevator pitch is, do you have great ideas to change the world for the better? Are you looking for partners to kickstart a project? Or do you just want to connect with Erasmus Mundus graduates in your city? Now you can. So Genie is a digital map, and I can do a example with you right now. Basically, you sign up, you put in your information, and then you would be mapped like this. So let's say you can click on Pepri. You can see which country and city he's currently based in, different skills that he needs, specific areas of focus. That's super interesting for me. And you can see that I'm here and Pepri and I are connected somehow, either based on our interest, based on our location, based on anything else. So you see here is Manasseh. He's also from the management board. You can see what languages he speaks, what skills he can offer, skills that he needs. So maybe we're connected. Maybe I need some help with something about legal, anything with legal. So I can be connected to him that way. I can search by people from skills here. Anyway, it's a really cool tool. Really amazing to see all the connections that are here. And you are all the students and alumni of Geotech are all invited to join Emma Genie. You can sign up on Emma's website. Basically, you'll get a survey link to your email address. You fill out the survey, and then the map access will be shared in a few weeks because we're currently populating the map with as many people as possible. So we're collecting all the survey responses because, of course, a project like this works super well when as many people have signed up for it. So then you will just receive map access in a few weeks once it's populated.
Thank you so much, Gabriella.
Sorry, did I go over time?
No worries, no worries. We're actually going to go on to our coffee break, but what a great way to stay connected by joining the Erasmus Mundus Association.
Yes.
So thank you so much for that. And if you'd like to share the link inside the chat for people to check out, and we will be starting our break. Okay?
Great. Thank you so much
Gabriella.
For having me.
Of course. Thank you for coming. If you have any questions for her, please feel free to stay at the networking event or send her some private messages, okay? Thank you, guys. Welcome back, everybody. Now it is time to start the exciting career development session. Last year was such a great time to get all of our questions answered about entering the professional world. And today I would like to welcome our 5 panelists. We have Dr. Paula Moraga, Assistant Professor at COST and Principal Investigator with the GeoHealth Research Group. Next, we have engineer Aisha Saif Shehi. She is the GIS Center Director at the Ras Al Khaimah Municipality. After that, we have Dr. Michael Gold. He's a GIS professor at Jammu University and a higher education head director for Esri. Then we have Ala Abdul Fattah. He is an employee of Conterra, our sponsor, and a geotech alumni. And last but not least, we have Dr. Benedict Grauler. She's a spatial data scientist with 52 Degrees North. Welcome, everybody. First, we'll have everyone introduce themselves. We've been introduced to Dr. Paula Moraga, but first we'll have her say hello. Are you here with us?
Hello, thank you for having me.
Hi, thank you. And Aisha, are you with us?
Yes, hi, I'm with you.
Hello?
Thank you again.
Okay, yeah, of course. And new to our conference today is Dr. Michael Gold. If you would like to briefly introduce yourself.
Hi, everybody. It's a pleasure to be here. And as was mentioned, I have been a professor at UHI for a while and also work with this guy at Esri. So 2 hats on. Thanks.
Thank you. Next, we have Ala Abdul Fattah. Are you with us today?
Hello, everyone. Yeah, I'm here. It's also good to be here. Good to see these familiar faces and to be here with you guys.
Thank you, Ala. And finally, Dr. Benedict Grauler, are you with us?
Hello, welcome everyone. Yes, thanks for having me.
Thank you. So now we'll get started. We will be accepting questions from the audience. So first, let's start a little bit of a dialogue. I have a question for you guys. How do you feel about entry-level students coming into the job force? Do you feel like we are prepared, or do you think that we need to stick to more entry level, or do you think we could come in at the intermediate level? What do you guys think about that? Let's start with Dr. Michael Gold.
Yeah, I think it's a good question. And of course, it depends on the people, right? It depends on the person. So one person who's at a entry level is not the same as another person. And it depends on the kind of work that people are looking to go into. So I think one of the things we'll talk about during this panel session is maybe the difference or the dichotomy between moving into a research career and becoming a professor or a researcher, or moving into industry. And so these are very different. Entry level as a researcher means something different than entry level working for a company. So I think, you know, people need to decide sort of what level they're at. Ala, for example, who was one of our students, right? When he went to work for Conterra, he was not a junior person. He had already had work experience previous to coming to study with us. So it depends. Be happy to talk more about that, but it depends on the person and the profile.
Yes, thank you. Does anyone else have any input?
Yeah, I would like to add something. Thank you, Dr. Michael. I will be talking with you guys today from the perspective of a software developer. As Dr. Michael said, I had quite a long experience before I started my master, so it was kind of easier for me to find a job. But I also saw like a lot of examples of people that even started to learn software development during the master, and they also solidified their knowledge for a little bit after the master, and they landed also like good jobs in Germany. So at least in Europe or in Germany specifically, the developers and the junior software developers are like really needed, and it's like a popular position. So I think whoever like started to do some work during the master related to software development and got like good knowledge, I think they have like a bigger chance, of course. I have no idea about the other field of like academia, but maybe we can hear someone else talk about this.
Okay. If you guys would prefer, we're going to move on to some questions from the audience with our co-host, Christian. Thank you, guys.
Okay, hi everybody. So we're going to start with some questions, so you can answer, please. First one, what are the possibilities and options for building your career in geoinformatics, according to your experience, your knowledge, please?
Well, if I may start, well, I see many different possible roads and many careers you could take after taking a geoinformatics master, probably. So staying in academia, of course, doing a PhD is one option, and pursuing the academic route. But also there are various types of business you can work in. You can kind of go to typical GIS developing possibilities and companies. You can also go more into a more research-oriented, like 50 Degrees North, where we kind of try to bridge between academia and the real world, and try to provide some solutions and develop stuff on really kind of cutting-edge software and cutting-edge frameworks. So there are many different roads, and they always kind of, you can switch between them. So it's not a one or the other. There are kind of many possibilities to jump from one to the other in between. Are there possible more answers to this simple question?
Okay, thank you so much. Can anybody? Okay, we're going to pass to the second question. This is particularly to Aisha. So in this case, what is the scope of job opportunities in UAE for geotech pass outs? What's the scope in your municipality?
Can you please repeat the question again?
Yeah, sure. What is the scope of job opportunities in UAE for geotech pass outs? What's the scope in your municipality?
Okay, we are currently under the municipality as a GIS center, but the scope of GIS is bigger than the municipality currently. So what we are trying to do under the municipality currently is to align all of the spatial component across the government. Sorry for my background. So it is not under the municipality only our responsibility, it is across the government.
As a follow-up to that question, I was wanting to pose a question to you, Director Shehi, about working in the Middle East. I was particularly wondering if it's okay if I can just come in speaking only English, because I know that when I was looking for jobs in Europe, for example, Netherlands, Dutch or German was required for jobs in Germany or Netherlands. Is it okay, like for public jobs in municipality and GIS, is it all right? Like, do they accept candidates that don't speak Arabic and can speak just English or other languages?
Okay, yes, most of the staff in GIS Center speak in English. So we are not speaking Arabic at all in the GIS Center, only with our management and with the, for example, the high management. But all of the employees talk in English language.
Okay, thank you very much.
Welcome.
I also have a question. I'm gonna take the mic by myself. And I wanted to ask everyone, actually, if you have an opinion, how much do you think this pandemic situation has affected the job market? For example, do you think employers are much more open to employing someone remotely, or is it still better to be closer to your workplace, like physically?
Okay, I will start on this question. For me, as a director of GIS Center, I'm starting now to distinguish between the work. I take a benefit of pandemic, and I will split the work who need to be directly in the GIS Center in the office, and the work should be work from home. So I'm trying to keep the people even balance between their social life and their work. So I keep it as a positive things, not negative, and try to limit the number of people coming to the office. This is one. Another is I'm looking also to have an expert from any country who will work with us remotely. So we are trying to do that also. So it is not a matter of bringing the people to the UAE and sitting with us in the office. It's okay. We can share everything anywhere in the world. Just now, we can see you. You are from Germany, and we are from UAE, so we can talk to each other. We can do whatever we need, I think, in future.
Thank you.
Yeah, I would say the situation is certainly changing, but that's something that we all need to be prepared for at all times. The situation will change all the time. And so this happens to be one crisis, but then there'll be another one, and there'll always be some kind of a disruption. Many technology companies are now happy to hire people working remotely because in the first place, we're having a hard time finding high qualified candidates anyway. And if we expect them to try to come into an office and travel now during this pandemic, it would be impossible. So I think many companies are starting to relax their requirements for people working in the office. And so this opens up new opportunities for people to work from home for a company that's maybe in a different country. However, I would caution people that it's not super easy just to sort of jump into a company being an unknown person working from home. It's a lot easier for them to know you and then allow you to go back home. So this is what I did when I joined Esri. I worked in California for 2 years, and then I asked them to come back to Spain, and they allowed me to because they knew me. If I had tried to do my same job from Spain, and initially they would say, who is this guy? How do we know he's really going to perform, right? So in many cases, they do want to have you sort of at arm's length. They want to be able to have face-to-face meetings with you to get to know you. It could be, however, that you already know some of these people. It could be you already know a company or an organization or a city government. And then I would say now is an excellent opportunity to try to take advantage of those opportunities and work from home. It's also good as a young person to get experience in different organizations. So it's a lot easier to work remotely from multiple organizations. You don't have to move your family to another place and find a home and school for your kids and all that. You can work a few months here and a year there for various organizations and get a more diverse block of experience.
Okay, thank you so much for your answers. I am going to allow one of my colleagues, David Sindua Alsina, to speak. So, David, you can speak.
Okay, can you hear me?
Yeah, we can hear you.
Okay, so basically, I'm sorry, there's an echo here. Hold on. Can you Yeah, is it I guess? Yeah, so just my question follows basically on what Professor Gold was talking about. So yeah, now more and more jobs offer you the opportunity to work from home, but this can be really difficult, especially when you're starting a company. And also, I believe, for example, in big companies, okay, let's say Esri, for example, you have different departments, and it might be difficult for someone with less experience to, because well, if you work from home, you're expected to have some level of independency in your work. So starting in a company and also, yeah, there's this expectation of being independent. I think it might be difficult with less experience. For example, you probably do not have much idea on how things go around in the company. So I think there's that distance or things. So this also is a bit of kind of discouraging, I guess, when applying for jobs, because you would think like it would be probably twice as hard for you to adapt or to get into the system in the company, because you would probably need to be able to work on your own and also kind of be able to, you would also want to build a relationship, you know, with the people you work with, because they would help you. Of course, in any company, you cannot work alone. It's a group kind of thing. So do you have any advice in kind of getting into a company now with this kind of situation, if you have to work from home? And yeah, I guess you have to kind of have some level of independence, and also how you can kind of get to have a better relationship with your colleagues, because yeah, this online thing gives you this kind of barrier that like you don't really get when you work physically in an office with someone, I guess.
I would like to answer to this question. It's a good question, David. I think in the software development field, it has been like always flexible for like people to work remotely, and actually the pandemic was kind of useful to help people understand very well that things can work this way. So I think that was an advantage for our industry. In Conterra, we started to work 100% from home, and we were 100% productive as we were in the office without any problems. The hiring process itself, I think it always starts like with like video calls if the person is not in the same city or in the same country, and then they invite the person over to have like an interview face to face, so that they get to know the person, and as you said, to build relation. So like I think it's possible to work remotely at some point, but you also still need to see the people and build the trust, because if you are not in the office, if you are working from elsewhere, there should be like a level of trust between you and the employer, so that they expect you to do the job as if you are in the office. I'm sure that there are maybe some companies that they do the whole process online for now, but I'm not aware of any. In Conterra, even before the pandemic, we were always looking for talents, and as Professor Gold said, it's always difficult to find like good people with with enough experience or enough like know-how. So we built this dream job configurator, in which you can configure your job and say exactly where do you want to work and how much hours do you want to work. And if you guys are interested, I will send you a link in the chat so that you can check it out.
Okay, thank you so much for your participation. I have another question. This is for maybe Dr. Paulo Moraga. So in this case, are you more or less on level of hiring, or at least taking people in for your organization or academia? In this case, what qualities do you seek for into your potential employee or subordinate if they want to be work for you? What could you consider like the main qualities or skills?
Well, so in my group, like as I said this morning, we develop statistical methods and computational tools for disease surveillance. So the people in my group have a good knowledge of statistics. They also have programming skills. They know how to program in R, for example. And then because what we want to do, we also collaborate with ministries of health and other collaborators analyzing data. We apply methods and we have our results, but we also want to develop tools for reproducible research. So it's not enough that the people in my work write a very complex statistical model and they keep the code for themselves. So what we want is to release the code to everybody, because maybe that code is useful for other people working in the same problem. Also because sometimes when you program, you make errors, and this can be seen by other people if they use your code. So what I'm looking for is people that know a lot about statistics and a lot about programming. And when they program, they know how to document the code and to make it easy to understand to other people.
Okay, thank you so much. Also, we encourage you as a panelist, the other panelists, to give us some recommendations, some support, because this is a frequent question that what is one soft or hard skills or experience that someone going in your sector in general should learn? So can each of you give us some feedback about this, please, to be more competitive? Maybe I could encourage Ala, please. Could you continue with this question?
Yeah, sure. Since you guys are all geospatial geeks, so I think that's of course an important aspect to that Conterra is looking for. Even if you work in the software development and the sales and the support, we have like many profiles that we are looking for. So of course the geographic knowledge, the geographic information system knowledge is usually important. But I encourage everyone that is into like software development to start learning something related to web development, because this is basically what we do in Conterra the most, like developing web applications for our clients, and usually we do like front-end development. So maybe learning one of the front-end famous libraries like AngularJS or Vue.js or React would be very beneficial to join Conterra or a company that is like Conterra.
Okay, thank you so much.
You're welcome.
Okay, I would like to encourage now to Dr. Ben, please, Groller, to answer.
Yeah, sure, thanks. Well, this fits well. Conterra is just next door, even though we today probably separated a bit more to home office and so forth. So kind of our main business is more on kind of knowledge intensive services. So programming is one part of the things we do. But what we would be looking for more is like analytical thinking, really, a strong interest in research. So really kind of also the way of research, putting up a question, talking about methods to solve it, to address it, to study the problem. So very strong interest in research. And what's very important often is the communication and visualization part. So if I have data, how can I generate some information from it, and how can I bring it to the customer and to the end user and decision makers, to the public? So these are very important questions. You can be a perfect programmer, but if you can't tell the story in the end, nobody will understand you and will understand the product and the service that you provide. And as part of that, it's maybe the ability to take the perspective of clients or of users and of the end user who's going to use your product, which is built upon data, of course. Data infrastructure is important, but also the entire analytics stack, how to go from data to information and how to communicate this.
Thank you so much for your participation. And also we proceed with Dr. Michael Gould, please, Professor.
Okay, it's a good question. And of course, again, it depends on the profile. If people think they want to have a technical job, then of course programming is very important. And it doesn't mean that you will be a programmer necessarily or will always be a programmer. But learning to program is a skill and it's a language. And so if you have programming experience, then it allows you to do the other parts of the job better. It allows you to better sell the solution to someone. It allows you to better train someone on the solution. It allows you to be an architect. These days, a lot of people are working, as Ala mentioned, are not working on a GIS per se. They're working on integration. So they need to build a solution for some client, which includes a little bit of GIS in the middle. But as we saw in the case of the municipality, it's connected to the SAP, whatever. It's connected to other systems, and so it's having the programming knowledge really helps to do the rest of the jobs later, to become a sort of a team leader or an architect or other things. And so I think people who somehow try to avoid programming, looking for other things to do, are doing themselves a disservice. In the same way that if you avoid learning, a second or a third language, or if you avoid statistics, you're doing yourself a disservice, because these are tools you'll use for other jobs in the future.
Thank you so much for your answer. We appreciate a lot. And finally, Ayesha, could you please give us also some recommendations, some advice?
I think she might have dropped off.
Yeah, thank you. Okay, I am going to allow one of the spectators, one of the participants, Mohammad Alaseweda, to speak. So please, Mohammad, could you please?
Can you hear me?
Yeah.
Yes, hello everyone. I have a question that now we are students and we are learning a new programming language and new skills. But how much the company willing to hire new students or graduated students who they don't have real experience in a real project? Maybe how we can convince them that we can do their work or apply our skills in their projects. Maybe they prefer to hire people have 1 or 2 years experience, and that's what that we don't have.
I might be able to reply to your question. So I was asked about what the skill that should a person have to be able to join.
No, I mean we have the skills.
Yeah,
we learned the
I
new
know.
programming language. Yeah.
I know. I just want to mention that my first answer, it was just like from the technical perspective, that yeah, this is the technical tools that you need to be able to do your job. But I think it's also like very important, as Dr. Ben said, to be able to communicate well what you are doing and convince the client or your manager about your solution. And this is very important, how to be like also like a culture fit in a company like Conterra, for example, because we also look for people to join and fit with the team and be able to collaborate. So it's very important to have like good communication and presentation skills, and be able to show your work in a way that is that is convincing to the employer that okay, this is how I did my work. So now there are of course how you communicate is important, but now also we have many online platforms in which you can build a portfolio and show your work in a nice way. So if you make a project during your studies, you can build something on GitHub or GitHub pages to show exactly the work that you've done, and it's a good example to show the employers that you can use your technical skills to build something that is that makes a value to the employer and at the end to the client. In our case also, if you are like looking for a job in Germany, it would be like a great benefit if you speak German because at the end yeah, you can like I still don't have like a very good knowledge of German, but I'm still learning. But it's important if you are able to communicate with our clients, because at the end our clients are all in Germany, and if you want to find a job in Germany, of course it will be easier if you speak the language. That would be my advice.
If I may say, I remember you last year saying you were gonna learn the German. You were learning the German language. We remember. We remember. You're still learning.
Yeah, I'm still learning. It's a long journey. So, yeah, and I like also learning while working. It's a bit difficult, especially in Münster. It's difficult to find like an intensive course. So I'm learning slowly, and like it's great at Conterra because they are very patient and they are paying my courses.
Very good, very good. Good advice. Go somewhere that will pay.
Yeah, exactly.
But let me just add on to what Ala said. I think it's a great idea to publish your work. So if you say you've studied a master's degree and you have experience with a programming language, I would ask, okay, so where is it? Show me what you've done. Point me to your GitHub repository, point me to your web page, point me to the, send me a link to your app. So it's not necessarily the case that you're starting with zero experience. It's just that you're starting with zero industrial experience. So you need to show people what you've done. And also you need to be out there being public, right? You need to talk about what you've done. You need to participate in the online forums. That's how people will find you. They're not going to find you because they read your paper CV somewhere. So you need to become part of the community.
And maybe a small advice to add. So whenever possible, try to start early and try to make contact with the company for an internship or for, well, if your study program allows to have like an external semester or so. So try to get into contact with the companies early and convince them why it's still kind of cheap for them to hire you and to get to know you. And then you have very good chances to step into the job afterwards.
Okay, thank you so much for...
Thank you for your answers. They're really helpful. We will work on GitHub repository now.
I have a question for the doctors. So how much did you guys have industry experience going into the PhD, or were you guys younger or older when you guys entered the programs? Tell me a little bit about each of your individual experiences.
So I studied mathematics, the bachelor's of mathematics, and then I started to work in a technological company developing algorithms for investing, like algorithms that maximize the rentability and minimize the risk. And when I entered in that job, I only had the programming experience that I learned in my bachelor's, so very little. So I work in the development of these algorithms, and then I work a little bit in software development. And after that, I decided to quit and to start my PhD. And in my PhD, I focused on spatial analysis of health data, and I acquired more skills in statistics and other techniques. But the thing is that by working in a private company before starting my PhD, it helped me a lot because all the skills that you learn by working in the company, collaborating with other people, and being productive and creating products that needed to be sold was very useful during my PhD. And these are things that you don't learn during the PhD. You need industry experience.
Thank you for your perspective, Dr. Moraga. What about you, Professor Gold?
So I also worked in both, and I kind of bounced back and forth. So I did my master's degree in New York State, and then I worked for a GIS company for a year, and then I went back to the PhD and did a PhD in GIS, and then I went to Spain and joined Esri Spain, and then I went back to the university, and then I joined Esri in California. So I've gone back and forth several times. So I can't say that's the formula for everyone, but I think that is a way to do both. I would caution people to try to do both by spending many years in one area and then trying to get out of that area and start the new area. The longer you're in one area, the harder it's going to be to sort of start somewhere else. But I think if you're doing a little bit of this, a little bit of that, then eventually you can be doing both. And both are wonderful experiences. We haven't said much about becoming a PhD student and then becoming a researcher or a professor, but essentially a PhD student is an internship, right? You're being paid, not a lot, but you're being paid a bit to learn how to become a researcher. And being a researcher is a wonderful pastime. You've got more freedom to do what you like. Hopefully you're in a department that supports you and allows you to do that. But it's a very nice lifestyle to be in. On the other hand, as was mentioned, as Paula mentioned, the industrial world is different pace. So you're expected to sort of have new ideas every day and new products every month and that sort of thing. So no such thing as sort of taking 3 years to think about something and maybe at the end we'll have a paper to publish. No, it's a different time frame, but neither is better or worse. They're different ways of working. So I would recommend that, to try to do both at the beginning and then see which you like best and then continue maybe in that direction.
Thank you, Professor. I wanted to ask, which part of California and New York did you come from?
Well, I was born in Massachusetts. I studied in Buffalo, New York, at the State University of New York at Buffalo, which has a sort of a famous GIS program starting in 1970. So it's a very old and a very established GIS program. And then I married someone from Valencia, and she kidnapped me and she brought me to Spain.
That's good. That's good. I'm hoping someone kidnaps me. I'm just kidding.
That might happen, but regarding the Esri offices, of course, I worked in the Esri home office in California near Los Angeles. But Esri has about 30 other offices around the world. So if people are interested, take a look at the Esri Careers website. I took a look at it just now. There are 234 openings. And so you can search for you can search for locations. You can say, I want to work in the Dubai office, or I want to work in Washington, DC, or wherever. And you can search on topics. So I want to work in something that's related to data, or something that's related to marketing or whatever. So it's not all programming.
Yes, I want to transition into programming. I have a background in environmental policy and planning, which is kind of humanities based and policy based, and a little aspect of GIS. And I worked in the professional world for about 1 year, and now I'm in the master's program for geotech, where I've been exposed to programming and mathematics, and I've developed a keen interest in these subjects. And I was wondering if you think it would be viable for me to transition into a PhD program focusing on mathematics and programming without having a strong background in the subjects. Dr. Ben Grayler or Professor Gold?
Well, I'm tempted to say it depends. So it really kind of depends on your supervisor and the topic you want to take. So if you have a brilliant idea for a topic where you say there's something I can work on, and I do have the well, all the possibilities to solve the problem and to tackle the problem, then it could work out. But it might be really tough. So you really have to be careful what you choose here.
Yeah, I tend to agree. I think it would be a little bit difficult to, quote unquote, start your mathematics career after a master's degree. I think you should probably have started already if that was going to be your intentions. But it's never too late, right? You can always start a new career. I think one thing to consider is that although we all love geographic information, we shouldn't think that now that you have a master's degree in GI that that's what you should be looking at and you should be focused on the geographic information world. There are plenty of PhD positions open. I see the emails all the time in places like Germany and places like Australia, Canada, the US. Many of them are not in GI specific disciplines. So there are people in business schools that are looking for people with our experience. There are people or there are organizations in biology and in other areas that are looking for this kind of experience. Smart cities research groups. So, you know, look a little bit outside of the traditional GI world, and I think you're going to find lots of possibilities where you can fit in just as well.
Thank you for that. I think we have some more questions in Q&A. Christian?
Yeah, there are two really interesting questions regarding that GIS science is becoming really into many topics for studying the art, the process, the social aspects, everything. We have one question that is really interesting. So what is one aspect of your career that you really love, and what is one part that you don't like? So this question is by Lucas Brown. So I will encourage to each of you to answer this question, please. Maybe we could start maybe with Dr. Paula Moraga, please.
Yes, so, well, I'm going to start with saying one thing that I don't like much, like in the university is so you are expected to produce like scientific papers. Like the more scientific papers you have, the better, no? And sometimes like people do research with that objective in mind. I need to have a paper. Like they don't spend time like going into an interesting question or creating a software package that can be useful. Like they only think in the papers that at the end is just that, like it's a paper, but is the things that we are rewarding. Yeah, and then things that I like a lot the flexibility, because if you work in the university, you can choose the project that you want to work in, and also be able to establish collaborations with other people and to start new projects.
Okay, thank you so much for your answer. So could we continue, please, with Ala?
So I've been always like enthusiastic about software development. So it's my passion. I like it. I like to do it every day. It's something very good. It's amazing to start a project from the beginning and work on it for a few months or a year, and then you find your output out there for people, making value and making sense. That's a very good feeling for me. But it's not always that you work on something that you like. So we also have to support maybe some old applications or upgrade some software It's not the main thing that I do, but I do it. I'm a professional, and I just work for the tasks that I have. So the good news is that these old applications or upgrading software, it's not gonna be old forever. So at some point, at least in Germany, we people are more progressive, and they also always like to use the latest technologies and stuff. This is also something I like a lot, that we are always trying to be up to date with the technologies, using the state-of-the-art products that are available, and about the cloud or about the container technology. So it's always also, there is always something new to learn, and there's always something exciting to research and know about and integrate in our work, and it always makes our life easier to use the latest technologies. But of course, you have to like that. You have to like learning, always learning. It's never ending.
Thank you so much for your participation. Indeed, yes, I agree that if we are related to these topics, GIS, science in general, any system has to be always updated, no? So we have to always progress in any activity. So yeah, I totally agree.
Yeah.
I would like to continue, please, if it is possible, Dr. Michael Gould. So what is one aspect of your career that you really love, and what is one part that you don't like, please?
I like most of it. I would say, taking a wide view, what I like about the geographic information world is that the people are very nice. People tend not to go into our field if they're these aggressive people who just want to sort of kill the competition and become millionaires, right? If you want to become a millionaire or do some, if you want to be an aggressive salesperson, go to work for Tesla or go to work for an oil company or something like that. But the GI and the GIS field, these are people who want to make a better world. They want to help people solve problems. I really see that everywhere, and it's very enriching. So it's a nice feeling. Not too many downsides, but I guess one is that we are always frustrated that people don't understand our field. They don't understand the value of geographic information and that sort of thing. And when you explain it to them, they say, yeah, but then they don't really get it. So that could be a little bit frustrating, but that's not a big deal.
Well, yes, thank you so much for your participation. And for example, related with this specific point, how can we as GIS researchers, GIS professionals, can we demonstrate, can we show to the society the importance of this? This is really, really important, really relevant for the society in general. Please, Dr. Michael.
Yeah, and hopefully other people have opinions as well. I think that we need to remember that not everyone is so crazy about maps and about geography as we are, right? And so we need to put our work and our results into the context that people understand. Other people are not so concerned about how cool geo is. They want to solve problems. They want to save money. They want to be more efficient. They want to do a better job at, vaccinating people, in some foreign country. So we need to find examples and show them, demonstrate how we're providing value to what they are doing. One thing I always tell my students is that as GIS people, we are sort of third order workers in the world, right? The first order workers, the people who are really, really necessary, are people like the farmers and the fishermen, right? And the doctors, right? If we don't have doctors and farmers and fishermen, we all die, right? But then we have people who are supporting these primary workers, right? And these are the people who are, the service providers and the teachers and everybody else. We're important, but not at the first level or at the second level. And informatics is designed to support those people. So we're sort of at the third level, right? So we do things that can make other people more efficient. And I think we need to remember that, remember what our place is, right? The world's not going to die without GIS, but we can make the world better with GIS.
Yeah, I think that's the most important part, no? That we can do a better work with GIS. Okay, thank you so much. And finally, for this question about what you really love and what is the part that you don't like, please, Dr. Benedict, could you answer?
Yeah, sure. So what I really like about the job here is kind of that we combine research results with combine results and methods to solve real world problems and kind of to address problems that help people and really provide a solution. So that's really great about it, and being still somewhere in the field of academia. And the downside is like you're moving further away from your studies and from your PhD in my case. You lose time to actually program stuff yourself. So you start to organize people and start to kind of delegate tasks to do stuff. And what I sometimes miss is really just kind of sitting down a day to program and just work on your own problem and solve it in the end, instead of organizing people around it to solve a problem for you.
Thank you so much. Now we have a specific question to Dr. Paola. Please, would you recommend KAUST for a PhD degree? And in this case, why?
Yes, so absolutely. Yes, so I think KAUST is one of the best universities in the world. So the PhD program in statistics is very good. The professors are super good. And also there is a lot of funding for PhD students. So the student will attend courses, but then when they are researching, they will have funding to go to many conferences, to visit collaborators abroad. So they will have a lot of experiences like that. And also living in KAUST is also very good because we live in an international campus. There are people from everywhere in the world. There are many activities to do. There are like, we are in the source of the Red Sea. So there are always things like snorkeling or diving. There are buses that go to Jeddah, that is the closest city to the campus. And this is very international and very young and there are people that are like, there are cinema, there are bowlings, there are gyms, and all of this is free. So PhD students here, they don't have to pay taxes, like the degree is free, and also the house is free, and they also receive a very competitive salary. So it's like you can focus on your PhD, and you have many activities to have fun as well.
If I may ask Dr. Paula a small question. How is it for a Valenciana to live in Saudi Arabia? I lived there like quite a long ago, and it was hell for me. So I know now it's like getting progressive, and like laws are changing and everything.
So as I said before, like I'm in the university, so I'm like, I dress like I want. I go to the swimming pool, I go to the beach, and it's the same. In addition, there are many people from Valencia here, so we have friends, and it's very nice.
Nice to hear in Saudi Arabia people can go to the pool.
Yeah, indeed, I think you encourage us, like most of us, to do the PhD there. So thank you so much for your participation. Okay, I am going to continue with one question from Mohammed. Okay, I'm going to. Yes, Mohammed, can you talk?
Hello. Yeah. I have a question. There are some people like to jumping from a company to another company, for who paid me more, I will work for him. They have this concept. But for the long term, that's affect them in negative way or in positive way. If you want to hire someone and look at his profile and see that he's working for different companies for a short term or for short time, did you hire him? you are, or no, maybe you will think that he will leave me in a short time, or he have a good experience, he work in different companies. I don't know if this is advantage or disadvantage.
I'll start with that. I think it's a good question. Certainly, the culture has changed. So one generation ago, people would join a large company and stay forever. And now the younger generation is accustomed to sort of joining and jumping, especially when they are in busy cities where there's lots of opportunity. I always look at people's curriculum vitas. I look at their resumes and I think, only a year here, only 2 years there. But it depends what they've done in their year. There are some people who could be very productive in a year and they move on because they've already reached their goal and now they want a better goal. There are other people who go to a particular organization for a year and they don't fit in socially or for whatever reason, and they basically are kicked out, right? That's a big difference, right?
Yes, you're right.
So one of the things we're looking for is what did this person do, even if it was only a year or 2 years? They did something productive and now they're moving on. Okay, that's fine. I'm happy to have them to come to my organization and do something productive for 1 or 2 years. So it's a delicate balance to try to figure out what's going on when you see people jumping.
Oh, that's really cool because I like to jump from company to company. I hate to stay in the same company for a long term, but senior people told me that will affect your opportunity. The company like people to stay with them for a long time. When you see you jumping, they will say no, that guy will leave us soon or in short time, so we will not need them. But really, it's a good advice. It depends what you are doing in this year. Thank you, Dr. Michael.
I would like to give you also a little advice, Muhammad, that it's always like good to move to earn more money, but trust me, if you feel good about what you have, it's good to stay. It's good to learn more and get experience in one place rather than moving, because you always don't see the negative, you don't see the positive side. So we tend to take positive things for granted and then complain about what's bad. And then you move to another company and you realize, okay, that I had some advantages that I never thought of, and now I don't have them anymore. So it's like you will never get the perfect job. There will be always some negative side about your job. So I encourage you to be like more positive, and as long as you don't have like big problems or you don't have like really financial issues with your salary or whatever, just stay and take more time and take more experience.
Yes, you're right. But I don't know if you are doing the same tasks for 2 years or 3 years. I think you will get bored and you want something new projects or new refreshments, something like that. That's in
Yeah,
my
sure.
opinion.
Yeah, sure. I think that's important. If you do the same thing for 2 years, it's a good reason to move, to find something more interesting. But I mean, if you learn, if you feel that you are like learning more, you have the freedom to do like more stuff, maybe you should stay a little bit more.
And I would also say that, before you just jump, hopefully you're smart enough to ask your boss, hey, I want more responsibility. I want more challenge. And maybe you'll get something better within your own organization. You don't have to look for it elsewhere. So you need to, if you want something, you need to ask for it. It can always say no, but if you don't ask, it'll be a no automatically, right?
Yes, you're right. Well, thank you both, Ala and Dr. Michael. It's really good advice.
Yes, and thank you from everyone attending as well. We are going to be wrapping up our career development panel session. Some of them will be available during the networking session, and they'll also be open to any private messages that they receive if you have any further questions. Now I'm going to pass it off to my colleague, Abdihia.
Thank you. Thank you, Gabriel. Moving on with the keynote presentations, I would like to introduce to you Dr. Linda Beal, who is the group lead for location analytics at Esri. Dr. Beal has extensive experience in the field of spatial epidemiology and has worked closely with several health departments, as well as the World Health Organization. She developed the award-winning Rapid Inquiry Facility Program for Chronic Disease Modeling and was co-author on the Landmark Environment and Health Atlas for England and Wales. Her presentation is going to be about the importance of relationship between epidemiology and the geographical perspective. In a world where epidemiology has gone from an almost unknown discipline to being part of our everyday language and lives, I think this topic is very interesting to today's audience. Welcome, Dr. Bill.
Thank you very much. It's good to be here.
Great. We will pass the screen now to you.
Okay. So hopefully you see my screen there.
Yes.
Okay, perfect. Okay, so as you say, I'm going to be talking a little bit about the relationship between epidemiology.
Excuse me, we can see the speaker screen, we can see your notes, so maybe you want to enter the presentation mode.
Is that better?
Yes.
Okay, perfect. Okay, so I'm going to talk about the relationship between epidemiology and GIS. And as you say, I've had experience both developing GIS, which is what I'm doing now, and also working in the field of research in Imperial College, London. So I'm just bringing this up. So I'm going to talk about how I see the role primarily from the viewpoint of a geospatial scientist. So that's kind of the viewpoint I'm coming from. Obviously, that's my experience. So that's the easiest ones for me to talk about. But also, hopefully, a position that you're all in, so that how you're all understanding it is. So I think that geospatial science is very much a bridging discipline. So it's valuable to many different problems that we have. We've already heard about, just in that last talk, how people see it as being valuable to solving problems. I also think that geoscientists have a unique set of skills and a different way of approaching problems. We're very much used to solving problems. So we are very good in terms of either doing research or developing software or whatever it is you're doing it. Having that idea of asking questions and what is it we're trying to do with this is a really good way of approaching anything. But I also think that solving complex problems requires us to have a very good understanding of the topic that we're actually answering those questions to. So let's start with this very basic start of what actually is spatial epidemiology. So we're seeing very much what we have here is kind of the original version of John Snow's talk. So he's very much seen as being the person who is kind of the father of epidemiology. And, you know, was he the one who actually started epidemiology? Or, I mean, I've even heard crazy things like he was the one who invented GIS. There's all sorts of stories about what John Snow has and hasn't done. So I'm going to start with what is kind of perhaps the true story of what went on. So John Snow was a physician, and he was the anaesthetist to Queen Victoria in England. And he very much pioneered the development of modern anesthesia. So he studied cholera throughout his entire career. He was very skeptical of the dominant theory that cholera was caused by miasma, which was what they considered to be bad air, and that cholera was an airborne disease. So he published his own theory on the transmission of cholera in an 1849 essay. Now the dates are important on this, called On the Mode of the Communication of Cholera. The outbreak of 1854 actually gave him more data with which he could actually go out and study what he was seeing and get more detailed data to back up what he already believed was very much true. So he did his investigations in Soho in London. They were based on the mortality reports issued by the Register General Office in London and evidence from a Reverend Henry Whitehead, who went out and talked to all of the residents at the locations, which you're seeing on the map in the top there. So he did identify the common factor within victims, that had begun dying in early 1854 were drinking water from the pump on Broad Street. So the local authority in that area responded to what John Snow had found, what he was able to gather from that data, and actually the pump handle was removed on the 7th of September, sometime after the outbreak had actually begun, and of course people still continued to die a little bit after that. The map itself was actually produced in 1855. So remember I said that he had started that work way before that. And that was published in his updated version of On the Mode. So Snow had already added to the body of work that he'd built up. And there's one last kind of myth to this story that you may hear from people. And that's actually that the map and the lithography that was used to create that map was done by Charles Cheffins. So he actually did all of the map creation and the cartographic and illustrative work. So it's important to sort of hear this story because a lot of the cartographic and illustrative work in scientific publications might be done by someone else. It's not necessarily the author, and a lot of those kind of the map makers behind it remain largely unknown, as in this case. So let's bring this along to modern day. And now we're seeing in that sort of bottom corner, the Johns Hopkins dashboard. So this is kind of the epitome of what we see as a viral map now. So everybody pretty much who works within this field has seen this. So this is a dashboard that's showing the distribution of COVID-19 cases across the globe. This has definitely, without doubt, shone the light on the geographic distribution of health events. So now this has become very much mainstream. People are seeing this, and I think the media is now using a lot more thematic maps because of this. It's become the norm. They know that the audience is accepting and is used to reading this. So it's done an enormous job in bringing people to realize how we can use this and bringing maps and dashboards and things to the fore. But my question is this spatial epidemiology? So we're going to explore this a little bit and see whether we believe at the end of that is spatial epidemiology, as some people will tell you. So I'm going to start by defining what spatial epidemiology is, or epidemiology as a whole. So clearly you will all, I hope, know what the word epidemiology is. It used to be that I had to start by explaining very much in detail what we do. Now everybody knows that in the middle of this pandemic, epidemiologists are helping us. They're doing the work. They're finding out what's going on with COVID-19. So COVID-19 is an infectious disease. So that is infectious epidemiology. But there are many different strands of epidemiology even within it. So just to give a very few mentions, you know, there's environmental epidemiology, there's occupational epidemiology, there's cardiovascular epidemiology, there is spatial epidemiology. Some overlap with difference. There's features of each of those that may overlap with other disciplines. But just to say, it is a very wide discipline within it. So how does geography sit within this? Why did I almost get into that field of it? Well, geography is very important to epidemiology, I would say. It represents the context in which the health risks actually occur. So space is the place that we live in, and there's place and there's space. So there's the people that we interact with, a lot more on the infectious side, and then there's the place that we live in, our neighborhoods, our environments, our experience. A lot of that also defines what we can and can't do, and it will also be an indicator of who we are. So that is the context in which those health events occur. So risk is also spatial. I would say it's also a temporal phenomenon as well, and we'll come to that a little bit. So the geography that we live in expresses that variability across where we're living and the experiences and the exposures that we have. There are very much inequalities in health outcomes. And again, that is a spatial feature. Depending on where we are, we will have different access to health, or we will be exposed to different bad health events. It also allows us to kind of see that as a framework for intervention, a framework for how we can go in and how all of the resources are allocated geographically. Depending on where we live, will depend on the kind of health services that we have, the doctors that we'll have access to. All of those features depend on where we actually live within the environment. So geography also provides that natural experiment, so we can see, and I know we will be looking at this retrospectively at the end of something like COVID-19, we'll be seeing how different areas responded in different ways and how that may have worked in some areas, and what is the commonality? What was it about that area that made it work? Was it the interventions, or as it will be a combination of a number of those different factors that came to work in that place, but we'll be combining different areas based on that geographic features, so based on the people who were there, based on all of the other things that we've already talked about, the variability, the health outcomes, the exposures that they had, and the interventions that occurred in those areas. So it also acts as a kind of a proxy for time. So we can and we should be learning a little bit from, okay, this area has now experienced a spike in cases, or they've been exposed to a certain industrial pollution and we've seen the effect on that population. We should not do that over here. So we can learn from things right now by watching different places. So the geography allows us to learn as we go through this. So how does GIS help us with all of this? Well, the first thing, the obvious thing, is we can visualize our data on a map when we start the analysis. That's very valuable. Just seeing those things on the map allows you to pick up any gaps or biases that you have in the coverage of your data. That information isn't necessarily something you would immediately see on a table of data, particularly as we are now, we're working with larger and larger sets of data. You're not going to pick out those problems. You're not going to notice something perhaps systematic within that data. Seeing that on the map, you can immediately see that. So I was doing several years ago when I was in London, I was doing an analysis of mobile phone masts and exposure to cell phones and cell phone towers. And we gathered the data from many different mobile phone companies. They sent me all their data. We compiled it all in a great big Oracle database. And the first thing I did, just being a geographer, was put it on a map. And immediately I saw that there was one region from one of the mobile phone operators that did not appear on the map. It was just a misstep. They'd forgotten to pick it up in the data collection, but I would never have seen that if I hadn't have mapped it. So in epidemiology, it's important also to understand that it's not the patient that we are concerned about. That's where it differs a little bit from doctors and medical analysis. We are concerned about the community. So it's very much about the population health. And we view these individuals collectively as populations. Slightly confusingly, within epidemiology, we call it ecological. It can be a little, it's kind of raises that idea that whilst we work together with other disciplines as geographers, we have to remember that sometimes there are different languages that we speak and we have to learn those terms that they use. But it's important to know that they're working ecologically as groups of populations, because that very much has implications for the study and the interpretation that we do. So we're treating the population that we're studying, we want it to behave in the same way. So we're looking for areas that are very similar. Now that assumption can be more or less true depending on the scale of the investigation that we're actually doing. So if you imagine you want to find smaller areas, so the people within those areas are more likely to be similar. Again, now we're talking about geography, we're talking about nearby areas are more likely to be similar than areas that are further away. So that's a fundamental thing within epidemiology. Shifting your data from one area to another is very easy if you're talking about moving from points to polygons. It gets a little bit harder when you're talking about different, moving from area to area. And we often find that the study areas that we're doing are inconsistent geographies. So there's an overlap in those areas. And we can shift between those areas. So we can shift between polygons. It's certainly very easy where you have that overlapping, where we have that intersection of polygons. And you can use that using area weighting. Now, actually, since I started at Esri, that has now become a tool within GIS. It was always possible. It was several steps, but you can see how the knowledge of epidemiology has already started to influence the creation of GIS, because that was a tool that I could see was useful. Now, you can still improve upon that. It's still very naive in imagining that the population is homogeneous across that area. So you can improve that by bringing in ancillary or extra data to which you then distribute that new population to and then aggregate it up. Again, possible within a GIS because we have access to all of that data and those tools. We can also see that there are georeferencing areas within when we're working geographically. So one example of that was when we were working with Ebola data, and everyone's used to using these clever georeferencing and we can geocode that data. Well, within the areas in the most recent outbreak across Sierra Leone, we were finding that actually a lot of those towns had pretty much the same name. They were 20 miles apart, so for us as epidemiologists, that's really close. But to them, it was a long walk, so the town had the same name, and suddenly all those clever algorithms you use don't work. And it comes down to local knowledge and actually working through that data. It's also good to know as a geographer that there is no correct projection. Now we know that. Epidemiologists might not know that initially. It very much depends on the area that you're studying and the question that you have. So are you dealing with distance calculations? Are you dealing with area calculations? How are you presenting those results? Are they going to be on a choropleth? In which case now you're seeing the area is very important in how you're doing that. So all of those tools, even though we're working with spatial epidemiological questions, really require a geographer, a geoscientist to have that input within what we do. So another key point is that spatial representation is the decision of the analyst. Now this is a crucial point that we know, and we need to remember that when we're doing our analysis. It's not an inherent characteristic of that feature. What we're doing is we're representing reality within a computer when we're working with something like a GIS. But it's a very crucial part of that analysis. So let me give you an example of that. If you are working with a point source of pollution from a factory, are we going to model that by the centroid of that area, that industrial area? And maybe the data you're given, this is where it is. It may be the polygon of where that industrial site is. But if it's a chimney stack that's polluting it, perhaps we want to find the exact point location of that chimney stack, which we do for all of those easily possible within a GIS. But which one we choose to do will also depend on the analysis we do. Are we going to do an advanced interpolation technique in which we're going to model that plume that's coming out? We're going to use things like the wind direction. We're going to exactly try and model that passage of that plume. Well, now the exact location may or may not matter. How accurate is your interpolation technique? Are you going to just take a 20-mile buffer around that area? Well, now maybe it doesn't matter. Are you going to take a 1-mile buffer, a 1-kilometer buffer around that area? Now maybe it does matter. So all of those things are part of that discussion, and that is a discussion with the epidemiologist. They need to be explaining to you what the impact of the exposure is, what you're looking for, and you need to be thinking about whether you need to convert that data that you were given in one format or another to something that may be more relevant to the analysis that you're actually doing. You also need to understand the underlying population. How homogeneous is it? You know, is there other data that we need to bring in to help us understand of those things before we can give the answer to that previous thing? So the decisions made are really the key criteria in what we're doing. It's important to understand those exposures and, as I say, have that conversation with the epidemiologist. So if we don't model our exposures correctly, that's going to lead to what we call a misclassification bias within your whole entire study. So it's a crucial part of picking that out. And in this case, I'm talking about if we actually are modeling the exposure that we're looking for in the population. I still see so many very advanced studies in very good scientific journals, and in terms of the epidemiology, I'm sure you can't fault them. But halfway down the paper, I'll see that they used inverse distance weighting, IDW, and they based all of their calculations over 20 years of this population based on what I would call probably really not the best kind of interpolation method in almost any case. So they perhaps would have been better with just a straight distance in some cases, because if you use the wrong method, you're actually introducing error into your analysis. But we do understand our interpolation a lot better. There are now, again, new tools that have been brought in, having understood a little bit of what is needed. So we now have things like EBK regression, empirical Bayes Krieging with regression. So that's combining as much data as you can to give you a better type of interpolation. So I've kind of already started to talk about this, but a lot of the epidemiological analysis we do will be done over many, many years. So over those years of data collection, that data collection is going to have changed. Now, somehow we need to either bear that in mind or take it into account in our analysis. So within health outcomes, they're actually collected using something called the International Classification of Disease, also known as the ICD. Now, these different codes change every few years. It takes several years to get them changed. Why they're changed is as we start to understand a lot more of the diseases. So we may understand there are different strains of the disease, different types of the disease that previously we've aggregated together as one grouping. We'll start to break them up. And what that means is all of a sudden, if you're doing a study over many years, a disease appears. Well, that's not because the disease has just appeared, it's because a new code has appeared. So look at it the other way. If you don't include that code number through working with an epidemiologist, you've now missed all of those events that have suddenly occurred and all of your results are incorrect. So again, it's that conversation between the epidemiologist and the geographer that makes for a good analysis. Different diseases have different latency periods. So a latency period for a cancer can vary between something like 1 year to 20 years. But even within the same cancer, something as lung cancer, that exposure association will differ depending on the exposure. So exposure to asbestos is around 19 years. But if you're talking about exposure to chromium, it's around 5 years. So there's a real detail to understanding what the epidemiologist will give you in knowing what you can study. Now, the spatial data also changes over time. So you can see something like the UK postcodes will shift between years. And some of those shifts are very large. So again, that underlying population is potentially changing. We need to look at that and understand. And that happens within all geographies across all of the world. And it happens within the boundaries. We change these census boundaries depending on the number of population and even in some cases the structure of that population. So we need to bear that in mind, how much that has changed. And as we move away from census years, be aware that your data is becoming less and less accurate. So every country will have their census data usually every 10 years. Some countries do it every 5 years. So as I say, as that's recently come out, that is probably as close as you're going to get to your underlying population. That's very important. That's your denominator data that you're including in all of your analysis. But as you get further and further away, as I say, for 10 years, your data is going to be more inaccurate. So if you look at something like the US now, and they're busy looking at COVID-19, we are 10 years away from the last census. The data of what you're hearing of the underlying rates is probably not as accurate as it could be because we're a long way away from those dates. We can model the data, So that's another thing to consider as to whether you're doing that. And also we need to think about the population. Depending on that length of exposure that we're looking at, that population is going to change. That population is going to shift within that period. So if you're talking about exposure to something within the environment, most of us used to spend 8 hours in our workplace, and yet almost all epidemiological studies will be looking at your home location. That may not be the exposure that you had. And now, of course, for a whole year, at least, our exposure has changed. Our exposure is now suddenly at our home addresses. So this is going to make for a very interesting study to see actually if modeling it at the home, it does make a difference, because now we can do that. But I would say we do really need to, this is an area we need to work in. And I haven't mentioned statistics yet. That is another crucial part of spatial epidemiology. And spatial statistics is making great strides in understanding temporal changes. But the spatial component needs to start to make those changes too. The way our data is structured within GIS is not ideal for doing spatial temporal analysis. Currently, a lot of people are kind of aggregating that up using space-time cubes, but aggregating data for spatial epidemiology is not ideal. We're already using data that's broken down by age and gender. So we can't be aggregating those data up into these groups because we need to understand the breakdown of the individuals. So this is an area that we really need to start to work in and understand how we can treat space and time equally when we already have a breakdown of multiple other factors within our analysis. So within our studies in epidemiology, what we do is we will select out the area of analysis that we're interested in and look at that to see if that population has been exposed, to see how that population is reacting or disease is spreading within that. So some studies within epidemiology do suffer from what they call tightly drawn boundaries. So what you do is you're essentially already defining the answer, because this is what they call akin to the Texas sharpshooter, who you fire the bullet and then you draw that target around it. And lo and behold, it's exactly at the center. So if you look to find something within an area, you're going to find it. You know, if you look for a cluster there, it's going to be a cluster. But what you need to do is look for it in comparison to other things. And again, that's where geography can help, because we can actually look at the map. We can also gather data from different areas, and we can expand that area. We can also find other areas that are similar. So we're doing true comparisons between like areas. If you tighten that area too much, you're going to have greater risk that you found within those areas, because you've got more expected cases. We need to have that comparison. What you get within also some of the studies is very small numbers, because fortunately, it previously used to be with non-infectious disease, you have only a few cases of things like cancer. Not so thing with things like COVID-19, we suddenly have large numbers. But with many sort of diseases that we're looking at, rare diseases, you're dealing with very small numbers. Now, small numbers statistically makes things very unstable. You have one case of it and you have 1,000 people living there. Whoa, suddenly you have a very high risk by the time you've put that into the statistics. So one way that we can do that is something called Bayesian smoothing. And what we're doing there is borrowing the information from other areas. So this is where you really see all of the disciplines come together. It's knowing that you can do that from the statistics. It's borrowing that information from the neighborhoods, finding the neighborhoods is geographic. And then in terms of interpreting it, then you take the epidemiologist to understand what all of that means. So by borrowing information from nearby areas that are most likely to be alike, then we're boosting up those small numbers and we're less likely to get those high risks that are just sort of anomalies within that data. We also need to standardize our data or adjust our data to have that true comparison. Like I say, age adjustment. We know that older people may be more impacted. And as you see now, that spans across multiple different epidemiologies. So infectious disease, we're seeing that with COVID-19. You'll also see it with things like cancers. They're more likely to be affected by those sorts of things. So we can take into account all of those things within a GIS. We can gather the data, but the problem comes, we're dealing with a breakdown of data. So this is where a flat data structure that we have within a GIS doesn't work so well. So again, I think GIS needs to, and actually is, starting to explore this idea of a lot better handling of their data with one-to-many and many-to-many relationships, so that you can truly treat all of that data together. Confounding is when we're looking at variables where other things are correlated with each other. And again, that's something that we can study within a GIS. So we can bring all of that data together, joining it spatially, and it provides a very good environment for that. So visualization, I talked about GIS is used for mapping. Fortunately now, we're actually extending beyond the map. And for many years, I've been lecturing that even though we do spatial analysis, the map is not always the best way for us to display that. We're seeing that more often now. People are starting to use charts and tables when they are more appropriate, even though it's spatial analysis that we've done. So displaying those results is clearly a key part of the study, and it's something that you should allow time for. You shouldn't rush into this at the end, get so bogged down and do your analysis and forget that you now need to translate what you found to the audience. They haven't been studying that for as long as you have, so now you need to make that very clear. This is particularly true if you're talking about complex topics, topics where there are features like uncertainty associated with that. Do people know how to translate what you're showing, and how can you make that clear? So I think in the past, there very much has been this tendency for people to not leave enough time and throw the data out. And again, this is going to be that conversation with the epidemiologists. They know their data very well, and they're very used to looking at these type of things. As a geographer, we need to step back and say to them, we need to explain this. But I think it's very important that we also remember that geoscience, GIS, all of the systems that we use are more than just displaying the health data. We are a part of that analysis. We are not storytellers. We don't just show the data. We are part of exploring that data and analyzing that data. And it's important that you all remember that and push the topic forward, push the discipline forward in itself, and don't allow it to be simply relegated to just the display of data. So I've talked through many different examples and reasons why I feel that epidemiology and GIS are so closely linked. And I really do believe that the sum of the parts is greater than the whole, that we need to work together. And that holds true for many different disciplines. We learn from other disciplines, and we can bring it all in and make our own field much richer for doing that. Epidemiology requires very complex data analysis, and we can actually provide a lot of the tools and expertise in order to do that. So many of you are going to find yourselves applying your skills in other areas and collaborating with others, and there are all those disciplines that you can learn from. There is a whole commonality within research questions. So you will find that the same questions come up, and working with us helps us learn from all of that and grow our own research and discipline. And for those of you sort of looking to move into developing geospatial functions, remember that any tools that we develop, or even if you're just creating your own free tools for people to download, remember that the functions you create have to be of use to people. We want to create something useful. So again, we have to learn and understand from others as to what they want from GIS. thank you. That's all I have to say.
Great, thank you very much, Dr. Linda Bill, for such an enlightening and constructive presentation. Virtual applause for you. I think it's kind of obvious the importance of the geographical perspective in epidemiology. And we will now open the floor for questions to you. Do we have any questions? We have 10 minutes for questions.
Yeah, I am going to give the word to Carlos, please.
Hi, Linda. I'm Carlos. I'm one of the organizers. I was really triggered by your talk because my background is in statistics and I have worked for a couple of years, 3 years in environmental epidemiology. And in 6 months, I will start a PhD in exposure assessment. So, and I was really sympathetic with the London postcodes in the UK changing shapes and codes every few years. That's very frustrating. Also, Bayesian smoothing, which is really nice tool. So my question is, as I am to enter this new world of, well, for me, of exposure assessment in the spatial sense, we're going to probably be looking at both personal exposures and then look at house-based exposures with spatial static maps. So I would like to ask you, what's your view on the trend of exposure assessment, to what the field is moving? What are the latest innovations? What do you think?
Well, I think there has been quite a few changes in exposure assessment. So now people tend to do it less statically, which is a good thing. It was very much a period when we went through placing monitors throughout an area and then doing interpolation based on that. And now there is a lot more of a drive towards people actually having monitors either on themselves or within vehicles is the most likely one, and then driving around the area. So that's going to give a lot better measures of exposure, and it does, because you're measuring it continuously across that area. It does also provide a slight challenge, because even though we are now measuring it and we're not going to be needing to do interpolation across areas, we're actually interpolating out from lines. So that's an interesting challenge, because I would say the geoinformation systems have not quite caught up with the fact that the data we're collecting is linear and that we're wanting to expand out from that. So to me, that's going to be your challenge, that you still need to do interpolation and you need to do it linearly. So I mean, the way to do that is to use all the ancillary data and kind of combine the regression and the interpolation so that you get the best of both worlds. But that's the interesting challenge, that whilst one feature has got much better, I don't think the other feature has, but it's certainly a good area to get into.
Yeah, it's really exciting also because the fact that you have a driving car with a monitor, if you have a monitor at every place you'll do recording for each timestamp, you'd have the measurement, whereas for a car, you only have one measurement per space per time. So I think this is extra challenging. So yeah, I'm really excited about this. Thank you very much for your answer.
Again, I think the other important thing to remember, though, is even though you're driving around, remember that you also need the background. So what is the background exposure?
Yeah,
and that's where the sort of the flat structure of monitoring sets can take it in, so you understand what the overlying background pollution is.
Thank you.
Okay, thank you so much, Linda Bill, for answering this question. Also, we have another question from the participants. So I think this is very, very relevant because, well, someone is asking that what data is important and what doesn't to understand spatial patterns in epidemiology, and also what is available and what doesn't. So it's related to the data acquisition, the data validation about the epidemiology.
So I'm not entirely sure what the question is. So you're saying what's important to understand?
Yeah, what The participant is asking about what data is important and what doesn't know to understand the spatial patterns in epidemiology.
So what's important, probably the most important thing is your population that you're studying. So actually, funnily enough, the most important thing is not the health data, because you're making all of your comparisons compared to your population. That's what's going to give you those rates. So the most important thing is your underlying population, essentially your census data, the data that you rely on other people for gathering for you. So that's kind of the key thing. The other key thing that you have to do is, as I say, because we're treating these groups, is know how to divide up your population into groups that are very similar. So what is the neighborhood that you want to study? Because if you are bringing in people who are very different within that area, then your denominator is way off, and you're going to I think the interesting thing with epidemiology now is we tend to be looking for things that are quite rare, things that are difficult to find. The reason they're difficult to find is there are so many interactions with other things. The very obvious things have already been found. And that to me is actually one of the nice things about the topic, because it really is looking for the needle in the haystack. So across everything, it's about defining those populations correctly, and actually your health data is the thing you need to worry about the least. Does that answer the question?
Okay, thank you so much. And also we have one more question. So recently there has been a huge focus on the improvement of spatial data infrastructure. So has this in any way helped in yielding more accurate results? And has it also helped in solving the spatial data and analysis issues in any way?
I fear not. I should be giving a really optimistic answer, but I don't think so. I think, in a funny way, I think research is really pushing it ahead. I would say no in terms of maybe off-the-shelf applications that you can buy, and I would say yes in terms of things like developing things in R and INLA and these types of programs. I think yes, they have, and I think they are pushing things, but I think we're still constrained by the way that GIS still treats everything as a flat data structure, and everything is attached to location. I think that can be a bit of a hindrance when doing spatial analysis, when we're talking about things like epidemiology. It will catch up though. I think, working within that area, it's kind of on that cusp when people are starting to appreciate that, there's a lot of complexity that we need to take account.
Okay, thank you so much.
Great, thank you. And may I ask one last question? You mentioned the ecological bias in your presentation. Do you have an example of your own experience?
Oh gosh, that's a good question. I don't think so. I was very, very fortunate to work with some very, very great teams of people. So we certainly, if we ever found anything like that, would strive not to have it. So no, I can't think of any cases. And I think that does actually kind of lead to a broader thing. I think the only issues that I do see within, as I say, papers that come out is it tends to be the GIS piece, it tends to be the geographic and the interpolation that's lacking. I think in terms of the epidemiology and the statistics, people are doing the absolute best that they can. I think it's on the geoscientists to thump their fists a little bit and say, no, you need to wait for us to do this better.
Okay, that is a very optimistic answer too. Let's all make an effort to cover this gap that there is in the research field. Thank you so much for being with us today. And Yeah, it was really an honor to host you.
It's a pleasure to be here.
Let me just start sharing my own screen. Okay, can you see it? Yeah, great. So this presentation concludes today's technical program. It was a full and very interesting day, at least for us. I think we could all get a glimpse of the potential and diversity of geoinformatics. And thank you so much for attending. Make sure to come back tomorrow for more interesting presentation and some hands-on experience during the scheduled workshops, which you can see an overview right now. The links to the workshops have been provided to you already by mail. And please make sure to meet the requirements before the workshop starts. And feel free to ask us in social media in case you have any remaining questions. Well, normally, the end of the first day is followed by a networking session over drinks. But this year, we had to transform the networking session a little bit. So we have prepared 4 different virtual rooms. The links for these rooms have been provided to you via email again. So you can just choose a virtual room, grab your own drink, and join us. The rooms will stay open for half an hour. And personally, I'm joining room number 2 in case you won't reach me. Well, I would like to express our gratitude to everyone that contributed to today's success. The keynote speakers, Paula Moraga and Linda Beal, the career panel, Paula Moraga, Michael Gould, Alaa Abdel Fattah, Benedict Grela, the alumni Daria Lutke, Ignacio Ponsoda Llorens, and Mahesh Thapa. Thanks to the presenters Alexander Strodman, Aisha Saif Shehi, and Gabriela Mikiewicz. And last but not least, the selected short paper presenters, Abhishek Pandey, Alba Villanova Corteson, and Giulio Pedrasoli, and Jordan Bates. Thank you very much again for attending. On behalf of everyone here in Lisbon headquarters, may you all have a wonderful rest of the day. Bye.
Thank you.